Good evening, Aditi. Good evening, Simran, Sarvesh, Karthik, Amulya, Saksham. Good evening. Please confirm. Am I audible? Ruchika, Janvi, Sheikh, Sama, Aman, Tejinder, Harsh, Shinchan. I am very nice. Okay, thank you. Okay, fine. So we are starting a bit early today. I'm answering that only, Mehak. We are starting a bit early today so that we can finish this topic now. Okay, I'm audible. Ruchika says excited for today's class. Okay, I hope you have been doing practice of these all questions, remainders and all for almost 1 week now. Yes, this class will be till 9, Yeshwardhan. Good evening, Ramu. Good evening, everyone. Rahul, Nandita, Anshika. I guess time is started. Yes, it will continue till 9 and आज हम काफ़ी सारी चीज़ें करने वाले हैं. So the things which we have done already, we'll have a quick recap. After that, remainders, there are some more remainder theorems which we need to discuss. Yes, if it is your first class, Sachin, welcome. You can certainly go through the earlier classes as well. After this, of course. Prince, timing is same 7 to 9 only. This class will continue till 9. So to the purpose of beginning it earlier is that so that we can finish this topic now. There are various things to do today. Don't worry, Shreya. You can always take a break in between. Okay, let's start. Is it important to watch non-engineering module, Sarvesh? Sarvesh, we are covering all the things in these sessions also. So those non-engineering module is for those students who consider themselves a bit weaker. So just to have a pre-knowledge or prerequisite knowledge, or basic knowledge, or basic go through all the topics, it is beneficial. But if you feel that that much you know, it's okay. Yes, Urvashi, we'll finish this topic of remainders and divisibility today. Right? Okay, let's start now without wasting any more time. So we are talking about the divisibility and remainders. Yes, don't worry. Timings are same 7 to 9. We are not changing the timings. We are just getting extra time. No, it will not end at 8:30. It will end at 9. No, Koshani, there is no problem. Okay, let's start now. So I would like that all of you please be very, very attentive to all the things which we are discussing. ठीक है ना? So I will mix Hindi also in between because many times I can see many comments Hindi. So don't worry, we are native Indians only. Priyanka is saying not audible. अरे बाकी लोगों को सुनाई दे रहा है ना? Are you able to hear? Priyanka, I guess I got the comment from all others earlier. They were able to hear. Others, please confirm. Are you able to hear? And Priyanka, if you are having any problem, you can refresh. Yes, it's audible. Thank you. Okay, let's start now. So we already discussed what are different divisibility rules and remainders, क्या होता है, how to calculate remainder, how to find remainder, and we discussed one remainder theorem also. Remember that was Euler's theorem or Euler's theorem भी लोग उसको बोलते हैं. And I could see that in your practice sessions, you were discussing about the CRT, Chinese remainder theorem as well. Although we didn't study it in our last class, so we'll cover all these parts today. So today जो पहले किया था मैं फटाफट से वो रिवाइज कर रहा हूँ. Don't worry, Prashant, it's English only. So it's English. There are North Indians, there are South Indians, there are everyone. है ना? So yes, आज remainder खत्म करना है. Yes, exactly, Raghavendra. Okay, so what we have discussed earlier, let's quickly recap that. We have discussed about the various divisibility rules. And in many of the remainder questions, we need to make use of those divisibility rules also. So we have talked about divisibility rules. And you have learned about the rule of 2 power n, 5 power n, right? We have discussed about divisibility rule of 3, 9. We have discussed about divisibility rule of numbers of the form, divisors of the form 10 power n minus 1 and 10 power n plus 1. So these are the basic kinds of divisibility rules which we have discussed. Basically this 3 and 9 also fall in this category only, right? 10 power n minus 1. So all these things we have already discussed. Fine. After that we started about the remainders part. Janvi, I'm giving that recap only, don't worry. No problem. I'm giving the recap of all the things, whether you are a new joinee or you are already existing student, don't worry. Still, recap is always beneficial. So after that, we discussed about remainders. So what are remainders? How to find remainders? So the basic point was, when any number is divided by any particular divisor, D. Okay? So there can be some quotient and whatever is the remaining part of the number, that is called the remainder. So that is a basic equation which relates number, divisor, quotient and remainder. Okay? So okay, we have discussed about all these rules earlier, so I will repeat that also Don't worry, Stuti. We'll do that in a while. So in these remainders, this number, divisor, quotient, and remainder. So we mainly focus on remainder because we get questions in our exam based on the remainder. We need to find the remainders. Okay, na? So when we are having such equation like this, so generally we omit the quotient part. We generally don't bother about quotient. So most of the time we write like this: when this number n is divided by a divisor d, which is also written as mod d. You have been using it in your various Facebook comments. So the remainder obtained is d. So this mod is the operation of division. When we are dividing a particular number with this divisor, whatever is the remainder obtained. So mod d we can write here, or don't write at all. That doesn't matter. Okay? So how to find remainder? We are dividing the number and getting the remainder. And we saw that if we are adding two numbers, so let's say there is number n1 and there is number n2. So if we are adding them and then we need to find the remainder with a particular divisor, so we need to find their individual remainders. So if n1 gives a remainder r1, they are having some different remainders. So we just need to work on their sum of their individual remainders. So when this sum is divided by the divisor, we can find the remainder. This we discussed. So while the number are being added, or the number are being multiplied, or the number are being subtracted, in all these cases, we can directly work on the individual remainders. अगर numbers को plus किया था, तो उनके individual remainders को plus करना होगा. अगर numbers were multiplied, then individual remainders need to be multiplied. If the numbers were subtracted, in that case, the individual remainders are to be subtracted. Basically, same operation. ठीक है ना? So all these things we have discussed. And after that, we discussed one remainder theorem. That was Euler's remainder theorem. So this was helpful when we are having a number raised to a higher power, like a number of the form something m raised to power some higher power, maybe m raised to power k. When this number is divided by a large number, mod n. When this number is divided by some divisor d. So how to find remainder? So here Euler theorem came into the picture, and what was that? Euler theorem discuss किया था ना सागर? हाँ, example अभी आगे आएंगे, don't worry. So we discuss here, we need to find कि number की कौन सी power ऐसी होगी जो उस divisor से divide करने पे remainder 1 दे. So what is the higher power of this number which gives remainder 1 when divided a particular divisor? For example, we took the case of remainder theorem was that m raised to power phi of n gives remainder 1 when divided by the divisor. That was the result of our Euler theorem, where this phi n is basically Euler number, phi n लिखें या e n लिखें, that same thing. How to calculate this, that we also discussed. And what was the condition to apply this Euler theorem? That this number and divisor should be co-prime. There should not be any common factor. Their highest common factor is 1. Right? So till this point we had covered in the previous classes. So let's take quickly some examples also, ताकि आपको easily समझ में आ जाए. Okay. इनके rules क्या थे? What were the rules? Let's start from here only. So 2 power n and 5 power n. What was the rule? They were having a common rule. That's why I have written them together. Please tell me first. What is the divisibility rule to check whether a number is divisible by 2 power n or not? And same way 5 power n or not. What is the rule? What is the divisibility rule to check whether a number is divisible by 2 power n or 5 power n? Yes, exactly. Thank you. So the number formed by last n digits must be divisible. Last n digits. So number formed by last n digits must be divisible. अगर वो divisible है, then number is divisible. Otherwise, whatever is the remainder obtained, we are getting the remainder. ठीक है ना? Okay. Then the next variety, चाहे वो 3 9 बोले, 3 9 is also part of that. So let's deal them separately. 10 power n minus 1, 10 power n plus 1. So 10 power n minus 1 का मतलब क्या हुआ? By changing the values of n, 1, 2, 3, 4, and so on, we'll get the divisibility rule for various divisors. And all of them are of similar type. That's why we are categorizing it as these two separate categories. ठीक है ना? By putting n equals to 1. Rule क्या है? पहले rule देख लेते हैं. So rule for 10 power n minus 1 was that we need to make groups of n digits at a time, and all groups are to be added. ठीक है ना? जो भी हमें ग्रुपिंग करना है, all these groups will be added in this case. And 10 power n minus n plus 1 वाला जब डिवाइजर है, in that case all the groups are to be alternate positive and negative. ठीक है? और ग्रुपिंग कितने कितने की करनी है? n digits. तो if n equals to 1, in that case मुझे एक एक डिजिट का ग्रुप बनाना है, मतलब single digit, and they are to be added in this case. In this case means 10 power 1 minus 1, that is 9. So whether I'm checking divisibility of a number with 9 or its factor, which is 3 basically. So what is the rule? Make a group of single digit and add them all. ठीक है ना? जिसको हम sum of the digits भी बोलते हैं, right? And same way अगर मैं इस केस की बात करता हूँ 10 power n plus 1, that is 11. तो वो rule for 11 will be again take single digit and alternate positive negative, starting from the rightmost end. The first digit from the rightmost end will be positive, then negative, positive, negative, and so on. So basically this grouping is always to be started from the unit digit or the rightmost digit. So these are the rules for 9 and 11, which we already knew without these terms, but we are going to extend it for further values of n also. If I take n equals to 2, so my divisor would be 10 power 2 minus 1, that is 99. So whether a number is divisible by 99 or not, so what we need to do, we need to make a group of two digits starting from the rightmost end of the number. And what we need to do with those groups, we just need to add them, add all the groups, and then we are going to get the final remainder. ठीक है ना? And now this rule is valid for all of its factors. What are its factors? This is 9 into 11. So basically for 9 we have this rule as well, that we can add two digits together, and this rule is applicable for 11 as well, and all other factors of 99 as well. Suppose कभी क्वेश्चन में ऐसा पूछा है, find the remainder when this number is divided by 33. Then what we need to do, we can again use the same rule. Ramu, you are asking about different divisibility for 13, 17, 19. We have not discussed that yet. Keep this in mind. We'll discuss about it later. We have not discussed about these rules yet. So for 99, so 99 के लिए जो रूल है 9 और 11 वाला, so this is valid for all the factors of 99 as well. तो रूल क्या है? We need to make groups of 2 digits together and starting from the rightmost end 2 digits का ग्रुप बनाना है और सभी ग्रुप्स को ऐड करना है. Add all the groups. Fine. And same way for n is equal to 2, this divisor become 101. Now 101 is a prime number, तो इसके तो factors नहीं हो सकते हैं. तो this rule is only valid for 101. What is the rule? Again, make groups of 2 digits at a time, starting from the rightmost end, and they are to be added and subtracted alternately. First group from the right hand side will be positive, then negative. ठीक है? Okay, and same way we extended it one more time for n equals to 3. When n equals to 3, that becomes 10 power 3. 1000 minus 1, that is 999. Now rule is obvious. We need to make a group of 3 digits and they are to be added, right? Now factors of 9999 are 27 into 37. So this is a common rule for 27 as well as 37. ठीक है ना? And for n equals to 3, 10 power 3 plus 1 is 1001. Now this is an important number. This 1001 is basically 7 into 11 into 13. So most of the times in our exams, we find questions based on the divisibility by 7 or 11 or 13. 13 one of you are asking also. So we can make use of this rule here. And that is important rule. This is beneficial if you are having a large number with many digits. ठीक है? तो rule क्या है? Rule वही है. We need to make a group of 3 digits at a time. And the digits are to be, the groups are to be alternately positive and negative. So this we had covered. I have just recap all the things. 27, 37 का अगर कोई पूछे तो 991 rule. Exactly. Yes, Tanish, that's perfectly fine. ठीक है, let's move further. We have discussed about this many time earlier and you have solved many questions also. अगर आपने questions solve नहीं किए हैं, so I will again recommend. So please solve questions. Please practice questions. You will get stuck in the questions, then ask your doubts. So there's a huge team to help you out, and you are more than 2,000 students here. And so all of you must help each other, and that's how you are going to learn. Okay, let's move further. So this was the recap of divisibility rules. So 13 is covered here. Someone was asking about 13, 17, 19. So 13 is covered here, but 17 and 19 we have not discussed because they are of not much use. There are many rules. We can create rules for many numbers, but वो ज़्यादा use नहीं होते हैं. So it's better to don't get indulged in that. But यहाँ तक sufficient है. यहाँ तक exams में आते हैं. 17 and 19 के लिए इस तरीके से हमारे पास rule नहीं है. ठीक है? तो अभी मैं इसको छोड़ रहा हूँ. फिर कभी we can talk about that. Okay. And this remainders, we had discussed all this part, how to find remainder, and we did this one theorem. So, कि कैसे power होती है? So let me take an example to recap this remainder theorem part. I'm erasing this. Any doubt till this part? नक्षत्र is saying 11 के लिए 2 या 1 डिजिट का ग्रुप साइमल्टेनियसली बना सकते हैं, जैसे 9 और 99 केस एडिशनल वाला था. No नक्षत्र, no. See why I'm saying no? Because in 9 वाले केस में हमने सिंगल डिजिट का ग्रुप बनाया था. We made group of single digit and 2 digit, 3 digit also together because we were to add all the groups. But in this case of 11, the groups are to be alternate positive and negative when we are making single digit group or group of 3 digits. In that case, the groups are to be alternate positive and negative. So that's why we cannot mix these up. ये रूल प्लस माइनस वाला है, वो रूल 11 जो दो ग्रुप वाला ग्रुप है वो प्लस वाला है, so we cannot combine them. ठीक है? 4 digits. Yes, we can extend the same rule which I have limited till n is equal to 3 here. We can extend it. If I put n is equal to 4, the rule will be for 9999. ठीक है ना? So divisibility by 9999. So we need to make groups of 4 digits at a time, starting from the rightmost end, and all the groups are to be added. That can be used, and factors of it are 99 and 101. So this rule is applicable for these divisors as well. Same way, on the other hand, we will be having a number 10,001. Right? The rule for 10,001 will be make groups of 4 digits at a time, and the groups will be alternate positive and negative. Now, what are the factors of 10,001? This is also important. This is 73 into 137. So sometimes we find this number also. Find the remainder with 73 or divisibility by 73. So in that case, we can make use of this. Okay? But this is not very frequently occurring in the exams. But this 7, 11, 13, that is the most important part. Okay, let's move further. ठीक है, हम आगे बढ़ते हैं. So now I'm discussing about this remainder theorem again, Euler's theorem. Let me erase this part. Okay, so before this Chinese remainder theorem, we had discussed about Euler's theorem. Now let me take an example for that. See, our question is find the remainder when 2 raised to power, say 100, is divided by 8. Yeah, 7. Find remainder when 2 raised to power 100 is divided by 7. Please solve it fast, everyone. Please solve it fast. Those who know how to solve, please do it. And those who are not sure, we'll just discuss so that we can continue with today's topic. Okay, Palak, Shinchan, some are saying 2 and some are saying 4. Please recheck. Okay, I can see many 2s here, but some are still saying 4. ठीक है, 4 वालों से पूछते हैं. Yes, Sagar, can you please write how did you get 4? And this who is this Libin? 2 power 4 mod 7 is 2. ठीक बात है. हाँ, that's okay. 16 mod 7 is 2. Okay, fine. You're using Euler's theorem. Nice. Wonderful. So 2 is the right answer. Yes, that's correct. 2 is the right answer. See, those who are not very sure how to do, many of you are doing this very nice. 2 की power, Sinchan is writing, sir, 2 की power and 7 के मोड का एक correlation होता है. I'm not remembering. अरे remember क्या करना है? Don't remember. Don't remember the results. Don't remember the values. Method we should be clear about. Sarvesh is writing Euler value of 7 is 6, right? So 100 more 6 is 4. Badhiya. So 2 power 4 more 7 is 2. Perfect. Wonderful, Sarvesh. Okay, so those who are not very clear, let me explain. So we had discussed about this. I want to find a remainder when this number is divided by 7. Now this is a large number, so it is difficult to find its value and then find the remainder. Even if we find its actual value, it is going to be a huge number. Then how will we find the remainder with 7? It's going to take time. So what was the purpose of using the Euler's theorem or any other theorem? See, CAT do not specify using any remainder theorems. I repeat, CAT do not specify that these are the syllabus, these are the remainder theorems which you need to cover. No, CAT only checks about the logical thinking, how you can solve it logically. So using these different remainder theorems is the purpose of using them is to make the things faster, make the things easier. But don't get complicated. How to solve this number? अगर exam में question आता है तो we have never studied any remainder theorem in until 10th class or 12th class or graduation or engineering, right? So how we can do it? So basically what we need to do, there are 100 2's multiplied, 2 multiplied with 2 multiplied with 2 and so on. There are 100 2's. There are 100 2's, 2 multiplied 2 like this, right? There are 100 2's being multiplied. 100 numbers are there. Now when this huge product is divided by 7, what will be the remainder? That is the purpose. So basically our intention is to find a group of 2's, that how many 2's when multiplied together gives a smaller remainder. Okay? A smaller remainder. So as some of you said that 2 power 4 gives 2 remainder, that's fine. The 2 power 4 gives remainder 2, again 2 power 4 gives remainder 2 and so on. We can make smaller groups. So the better will be the case. Now Euler is telling us here that what is that power of 2 which when divided by 7 gives remainder 1. So if I get that itne numbers ka, itne 2's ka group bana lein, that is going to give us remainder 1. The process is going to become easier. So Euler said to us, Euler told us this value, that when a number is raised to power phi of the divisor, or basically Euler's number of the divisor, remainder obtained is 1 with that particular divisor. And I have told you that condition to apply this is that number and divisor must be co-prime. Okay? So in this case, 7 and 2, they are co-prime, they are not having any common factor. So I could have checked here. See, 2 multiplied with 2 is 8, and 2 into 2 is 4, 4 into 2 is 8, right? 2 power 3 is 8. Tell me, yes, perfectly. 2 cube when divided by 7 gives remainder 1. So this was a small number. Without knowing the Euler theorem also, you could have found that 2 into 2 into 2 is 8, and 8 को जब आप 7 से divide करते हो, that gives remainder 1, right? So it was 2 power 100. So if I make groups of 2 cube, that is 8, again 2 cube, that is 8, again 2 cube, that is 8. So how many groups can we form? 33 groups. Right? And now I will be left with one single 2 here. Is it not? Right? And now each of these 2 cube, which is 8, gives remainder 1. So 1 into 1 into 1, chahe kitni bhi baar ho, how many times it may be? So it's 1 into 1 into 1 into 1 into 1, 33 times into 2. So 1 into 2, that is 2. So 2 is the remainder. So because this was small number, we could have very easily find that what is the power of 2, which gives remainder 1. So we got our answer. But if this is a large number in which it is not very easy to find that what groups, groups of how many numbers, product of how many numbers is going to give us remainder 1. In that case, we prefer to use Euler's theorem. And Euler's theorem, as I said earlier also, this directly tells me that whatever is the divisor, find the Euler value, Euler number for this divisor phi, and then we can find the remainder. Because that particular power is going to give remainder 1. ठीक है ना? कौन सा साइड वाला कॉन्सेप्ट समझ नहीं आया? मिस हो गया ये गुंजन, वो साइड वाला कॉन्सेप्ट क्या है नहीं समझ में आया. अरे यूलर थ्योरम इसी को तो बोलते हैं. दैट्स यूलर थ्योरम. That's Euler's theorem. See, in place of 2, if it had been, let's say, let me change some number. If it is maybe 23 power 100 divided by 7. Please everyone try to find the answer. I will come to that part, don't worry. मानो मैं बोल रहा हूं 23 की पावर 100 है, 23 raised to power 100. Now find the remainder when this number is divided by 7. How will you do it? Do it fast. Gunjan, I understood. Okay, many of you are getting the answer 2 again. Now this time it is 23. I've changed the divisor number. Yes, still the answer is 2. And yes, Dviti again. Yes, Shinchan, that is perfectly fine. Why it is so? Why it is so? Yes, thank you, Harsh. See, now I do not know when 23s are multiplied together, then what power is going to give me remainder 1. So what we could have done, first we find the remainder of this 23 with 7. If we divide 23 by 7, what is going to be the remainder? It is 2, as I wrote here. So if this number is basically 23 multiplied with 23 and so on. Right? There are 123s. And when we have to divide it by 7, so as I wrote earlier in the last screen, that we need to find the individual remainders. We have to work with the individual remainders. So when this 23 is divided by 7, remainder is 2. Right? Because 21 is divisible, 2 remainder. Again 2 remainder. Again 2 remainder. So effectively this question is same as that of earlier. It's the same process. ठीक है ना? Okay, यहाँ तक की बात ठीक है. CRT पे भी आते हैं. Don't rush to that. अभी हमने CRT की बात स्टार्ट नहीं की है. We are just talking what is the remainder, why we are using the remainder theorems and how to use those remainder theorems. So basic purpose was to find that power of the number which gives remainder 1 when divided by a particular divisor. ठीक है, मैं फिर से बोलता हूं, हमारा पर्पस क्या है? Our purpose is to find that power of the number which gives remainder 1 so that we need to work with a smaller power. ठीक है, okay, let me change the divisor also. Now divisor is 17. Same number 23 raised to power 100. Find the remainder when it is divided by 17. If power is smaller, in that case, Euler is not going to help much. Now find this answer. And now I'm going to discuss again that how to use this Euler's theorem also. Because now this number is the large one and divisor is also a large one, 17. Now see how to solve it. Okay, someone is writing answer 4, 6 also I am able to see. ठीक है, देखते हैं, let's see here. See, first thing what should we do? We should find the remainder of this 23 only. So 23 power 100 basically means 23 is multiplied with itself and total 123s are there, right? These are 100 numbers. ठीक है ना? We are dividing by 17, that means mod 17. So I'm not going to write this mod 17 repeatedly. Let it be there. Okay, 17 से divide कर रहे हैं, तो can you tell me what is the remainder when this 23 is divided by 17? It is 6, right? When 23 is divided by 17, remainder is 6. So this gives remainder 6. Again, next number also gives remainder 6. Again, next number also gives remainder 6, and so on. So basically, this number is 6 raised to power 100. We need to find this number's remainder with 17. Till this point, is it okay? Yes. Okay, I can make use of the remainder theorem directly if I wish here, but that also going to help me in a limited way only. थोड़ा सा काम बचेगा, but can we simplify it further? Can you tell me without using any remainder theorem that what will be the remainder? What will be the power of 6 which gives remainder 1? It will be difficult, but we can break it into two powers. I can club 2 6 together. Let's say 6 into 6 is 36, right? And 36 when divided by 17, what will be the remainder? 6 into 6 is 36, right? 36 को जब आप 17 से divide करोगे क्या remainder आएगा? 17 2 34, 2 will be the remainder, right? इसको अगर मैंने 17 से divide किया, यानी कि 36 को 17 से divide किया, remainder is going to be 2, isn't it? That's a small number. That's a small number. It will work, right? तो अगर मैं यहाँ पे 36 वाले ग्रुप बना लूँ, तो basically this is going to be 36 raised to power 50. Is it fine? ठीक है ना? Okay. Now each 36 gives remainder 2 with the divisor 17. So basically, I need to find my remainder from 2 raised to power 50 because each of this number is giving remainder 2. Is it okay? I have not used the Euler theorem so far. ठीक है, अभी तक मैंने इस थ्योरम का यूज नहीं किया है. Let's move further. Now can you think of any power of 2 which can give a smaller number, smaller remainder with 17? Yes, 2 power 4. 2 power 4 is 16. 16 को 17 से divide करेंगे तो remainder is -1, right? ठीक है ना? Right. 2 power 4 करेंगे तो 16. तो let me write it here. Now my target is to find the remainder when 2 raised to power 50 is divided by 17. That's what I need to calculate now. I have not used the remainder theorem so far. And as I said earlier, CAT does not require you to use the theorems only. Theorems are to make the things easier and faster. And that they will work if you understand the basics. Yes, I could see in the Facebook group that you're practicing a lot of questions. That's a very nice thing. Okay, see here now 2 power 50 mod 17. Now 2 power 4 is 16. Let me write it here. 2 power 4 is 16. तो 16 वाले कितने ग्रुप्स बन जाएंगे इसके अंदर? So 4 वाले 12 groups, right? 12 4s are 48 and 2 square, that is 4 will be remaining. Till this point it is fine. I don't prefer to use mod 17 repeatedly, but anyway right now I'm writing it. ठीक है, so now 2 power 4 is 16. 16 को 17 से divide करने पे remainder is -1, right? Now this is -1 raised to power 12 multiplied with 4. अभी -1 raised to power 12 means 1 only, so basically remainder which we are looking for is 4. See, I have not used the remainder theorem at all. We are just breaking it down in the simpler forms. Is it okay? Okay, now let's use the remainder theorem. So remainder theorem directly tells me that I can directly find the power of 23. What power of 23 will give remainder 1 when divided by 17? ठीक है, तो what remainder theorem is telling me? Let me create this some space here. I'm removing this part. Okay, now let's use the remainder theorem. So remainder theorem, this Euler's theorem tell me because this number 23 and 17 are co-prime, their highest common factor is 1, so we can apply this theorem. Okay, now this theorem says find the Euler value phi or E of this number divided 17. So Euler number value phi of 17, how to find this? Because 17 we need to do its prime factorization. 17 is a prime number only, so for prime numbers we have done it, it directly comes out to be 16. Basically it is 17 into 1 minus 1 by 17, which gives you 16. So as per this Euler theorem, it says that 23, this number, whenever it is raised to a power of 16 or any multiple of 16, it will always lead a remainder of 1 when divided by 17. That is the direct result from Euler's theorem. Okay? So that's the result of Euler's theorem. Now Euler doesn't claim that the 16 is the smallest power. इससे छोटे भी power हो सकती हैं. गुंजन, if you will not see here, how Euler कैसे समझ में आएगा? Euler धरा के तो समझाएगा नहीं. So using Euler's theorem, we need to see whether the condition is being satisfied, and condition was that highest common factor of the number and divisor should be 1. So in this case, the number is 23 raised to power something, so basically 23, and the divisor is 17. So we have seen that they are not having any common factor. Their highest common factor is 1. So we can apply Euler's theorem, right? And how to apply the Euler's theorem? Tell me that phi value, Euler's value, when this is the power of the number, that will give remainder 1. So how to calculate this Euler value? For that we need to find the prime factorization of this number. Now prime factorization, this is a prime number only, so this is 17 into 1 minus 1 by 17, that is 17. So 23 power 16 gives remainder 1. Okay? Now the next step. Till this point is it okay? That is the result given by Euler's theorem to us. Now further, what is the nearest multiple of 16 till 100? 6, right? So 16 into 6 is 96. So according to Euler's theorem, 23 raised to power 96, which is basically multiple of 16, that is going to give us remainder 1. So what is left now is 23 raised to power 4. So that is what remaining on which we have to work now. So 23 power 4, let's work on this. Somebody was asking what is the meaning of these 3 lines here. It is just mean they are equivalent. Because they are not exactly equal, we are writing remainder only. So what will be the remainder? From 23 power 96, I'm getting remainder 1, so no need to write that. Right now I'm writing 1. And 23 power 4 से मुझे remainder निकालना है. So how to calculate that? As I was doing earlier. So 23, it is written multiplied 4 times. So 17 से when we divide 23, so each term will give us remainder 6, right? So it is 6 power 4. Now this 6 power 4, again 36 into 36 we can do. This is 36 into 36, and each of the 36 gives remainder 2 when divided by 36. So it comes out to be 2 into 2, that is 4. So using Euler's theorem, directly we could have reached to this part. That is the benefit of using Euler's theorem. Okay? Let's move further now. So there may be situations, in the last class I remember many of you were asking, what if the HCF of the number and divisor is not equal to 1? In that case, what can we do? So in that case, what we can do? So let's see now. In that case, this Chinese remainder theorem is going to help us. Negative remainder abhi humne use kiya tha na? 16 was giving remainder minus 1. We use that. Yes, we can certainly use negative remainder wherever possible, wherever beneficial. Let me take one more example for that. जल्दी से बताइए, what will be the remainder when 16 raised to power 100 is divided by 17? Please write your answer fast. निर्णय is asking 23 power 96 कैसे आया? इससे स्लो मुश्किल है भाई. We saw निर्णय in the last question, we saw that Euler value of 17, the divisor, was equal to 16, right? So 23 raised to power 16 will give remainder 1 with 17. And 23 power 16 के अगर आप this is 23 power 16 k. If you make 6 groups, that makes it 96. So that is also going to give remainder 1 into 1 into 1 6 times. That is 1 only. And our total power was 100. That's why 2 power 96 multiplied with 2 power 4. Now this term gives remainder 1. So 23 tha. So we were just focusing on this part. Okay, answer to this one? Yes, it's 1. In this case, negative remainder. Right, it's minus 1. So in this case, it is better to use the negative remainder because 16 raised to power 16 will give remainder 1 with this divisor, that's fine. But directly we can see that 16 gives remainder minus 1. So this is minus 1 raised to power 100, that is 1. No need to use Euler's theorem here. Okay, na? Okay, I hope the previous part, whatever we had done, that should be fine for those who are hearing properly. Class abhi start hui hai Shubham, we are just revising the previous part. Now we are starting today's part. I was waiting so that all of you may join. Okay, let's move further now. So our now basic thing is, what if the number and divisor are not co-prime? They are having some common factor. They may have some common factor, or even if they are not having common factor, but the divisor is a large number. Okay, so let me take a small example. Let's take example of that part only. See, agar aisa hai kahin pe, I need to find the remainder when 2 raised to power 96 is divided by 96. Please solve this one. Find remainder when 2 raised to power 96 is divided by 96. In today's class, we are going to discuss many things, many things. So it would be better that you avoid the side talks. I can see a lot of unnecessary comments here. Yes, 2 power 96 when divided by 96. Now see, they are not co-prime, they are having common factor. And this is that trap question only. Abhishek Kumar Singh says 1, Shreya, 2, Aarti, 2, Joy, 2. Yes, they are not co-prime now. Yes, how will you solve it? Mrigang, Shivansh, they are also saying 2. Yes, exactly, Suki, they are not co-prime, so we can't use Euler theorem here directly. Because there was a condition that they must have been co-prime. Remainder 1 तो हो ही नहीं सकता, वंशिका. अरे CRT रुक जाओ भाई, चिराग. I will come to that. Okay, let's think logically. Can you tell me what is the highest common factor of this number and this divisor? Just think logically. Okay, one answer I'm seeing now. Anshika is written 64. Harsh says 64. Shinchan, you need to post the comment again. I'm unable to see that. What is the highest common factor? First, tell me that. HCF is 2. No, Harsh. It's more than that. This is 2 raised to power 96. This number is 2 raised to power 96. Yes, Abhay, 32. Yes. 32 is their highest common factor. Yes, HCF is 32. Now, as I was saying, just think logically. This number is a multiple of 32, right? This number is multiple of 32. And this divisor is also multiple of 32. This is 32 times 3, isn't it? So, remainder basically means we subtract the divisor repeatedly from the number, isn't it? Let me say it again. This is a number, large number, which is multiple of 32. 32k, मान लेते हैं. And this 96 is also multiple of 32. Actually, it is 32 times 3. So, when I subtract this divisor from this number repeatedly, that means I'm subtracting this multiple of 32, many times, 32, we are subtracting the quotient into some quotient, right? 32 into basically q dash, jo bhi. So, if I'm subtracting two numbers, both of which are multiple of 32, their difference is always going to be multiple of 32. Is it not? Let's try to understand this thing again. You are telling the answer, Arnav. Okay, many of you are writing the answer, but understand this basic thing. These numbers are not co-prime. They're having some highest common factor. Here, 32 is the highest common factor. So this number is multiple of 32. I wrote it, let's say 32 into k. And this number is also multiple of 32. So to find remainder basically means we are to subtract the divisor repeatedly from the number. Till we get a positive quantity less than the divisor. So 32 का केस में से subtract करेंगे तो 32 into some quotient q dash bar. So this difference is going to be multiple of 32. So basically answer is certainly going to be multiple of 32. अब 32 कैसे आया? Because 96 is 32 into 3. This 96 is 32 into 3. 32 means 2 raised to power 5, and 2 power 96 is certainly multiple of 2 raised to power 5, isn't it? And 3 is co-prime with this n power of 2. So that's how we got to know that highest common factor is 32. So basically point is that whenever our number and divisor have some common factor, so the remainder is always going to be multiple of that highest common factor. यहाँ तक की बात ठीक है? Okay, now how to find that remainder? In that case, this Chinese remainder theorem is going to help us. How we can do that? Let's see it here now. We could have used cyclicity also. Many of you were writing that. Let me discuss that part also before I move to this Chinese remainder theorem, which is a direct remainder theorem. हाँ, तो co-prime हमें पता चला because of factorization. Because of factorization, we could see that this number 96 contains powers of 2. It is 2 power 5. That is 32 into 3. And this 2 power 5 is contained in this number as well. So 32 is their highest common factor. So basically, remainder is going to be multiple of 32 always. Okay? Answer 64 is correct. Let's check out how. Some of you are able to do that. Some of you are asking how. Till this point, I hope this should be clear. Urvashi ji, I'm repeating once again. This number, let me take another example. If a number is multiple of 5, 5a, okay? I'm subtracting another number from it, which is multiple of 5. Now tell me, can I say that their difference will be multiple of 5? Yes or no? Will their difference be multiple of 5? Yes, that's what we are discussing. So in this case, this number is multiple of 32. This divisor is also multiple of 32. So when we are subtracting them, so the answer, the remainder is going to be multiple of 32. So when some of you are asking, saying the answer as 1 or 2 or something, that's why I said, just think logically, the remainder is certainly be going to multiple of their highest common factor, which is 32 in this case. Okay? ओके हाँ जो कह रहे हैं लास्ट एप्लीकेशन क्लास में आपने कुछ किया था ओके ठीक है हाँ लेट्स टॉक अबाउट दैट सो हाउ डिड यू डू इट उसको भी कर लेते हैं सी 2 पावर 96 96 आई एम टेलिंग ऑल द मेथड्स अदर देन चाइनीज रिमाइंडर थ्योरम फर्स्ट उसके बाद चाइनीज रिमाइंडर थ्योरम पे भी हम आएंगे सो 2 पावर 96 का हमें 96 से रिमाइंडर निकालना है सो आई एम राइटिंग इट लाइक दिस आप इसको ऐसे समझिए ध्यान से सो आई वांट टू फाइंड दिस रिमाइंडर देयर हाईएस्ट कॉमन फैक्टर वी हैव जस्ट सीन इट इज 32 सो उसको कैंसिल कर दो या यूं समझ लो उसको अलग से बाहर निकाल लेते हैं सो दिस रिमाइंडर इज गोइंग टू बी मल्टीपल ऑफ 32 This final remainder is going to be multiple of 32. So उस 2 power 5 यानी कि 32 को अलग निकाल दें तो नंबर क्या बचा 2 power 91. Basically I have taken out that common part out. तो जो common था 32 उसको cancel नहीं करते हैं. I saw it just before this class. There was a comment. There was a question asked by some of the I think any one student I don't remember the name. So उसने कुछ ऐसा किया कि दोनों को काट दिया. Let's say अगर 40 को 30 से डिवाइड करके क्या रिमाइंडर आएगा if it is asked तो can we say कि 0 से 0 cancel 4 का 3 से रिमाइंडर 1. Is it right? If you divide 40 by 30 तो will the remainder be 1? No. So it's not that when they are having some common factor, it's not that cancel that out. That will be what is the process then? तो अगर 40 को 30 से डिवाइड करने पे रिमाइंडर निकालना है, if I want to find this remainder, so 10 is the common factor. That will not be cancelled out. So that will be multiplied with the remainder of the remaining number, which is 4, with the remaining divisor. अब 4 को 3 से डिवाइड करने पे रिमाइंडर is 1. So final answer is 10 times 1, that is 10. That was a simple example, small example to understand the basic concept. So whenever number and the divisor having some common factor, in that case, we need to multiply their highest common factor with the remainder of remaining number with remaining divisor. Okay? Let's see here now how to apply this. So this was 2 power 96, 96. Highest common factor was 32. Now remaining number 2 power 91 and remaining divisor, it will be 3. Isn't it? We have just taken out that highest common factor. 2 power 96 में से 2 power 5 निकाल देंगे तो कितना बचेगा कार्तिक? 2 power 96 में से if I'm taking out 2 power 5 it's 2 power 91 ना ठीक है so as we just saw here so whenever we are dividing a number and divisor which are having some common factor so in that case their highest common factor is not to be cancelled out उसको cancel नहीं करना है that is wrong way we need to multiply that highest common factor with the remainder of the remaining numbers so here 2 power 91 को 3 से divide करना है now it is very easy each 2 gives remainder -1 right I can use negative remainder here so -1 raised to power 91 that is -1 only -1 को पॉजिटिव कर लेते हैं तो क्या बनेगा 3 से रिमाइंडर निकाल रहे थे it is going to be 2 32 need to be multiplied with this so this is 2 basically that is 32 into 2 which is 64 which most of you are answering so 64 is the right answer here ठीक है okay अभी तक मैंने उस चाइनीज रिमाइंडर थ्योरम की बात ही नहीं की अब उस पे आते हैं till this point is it okay so basically we have covered that part which you were asking last time what will happen when the number and divisor have some common factor Okay, let me give you one question too, so that I may confirm कि आपको समझ में आ गया कि नहीं आ गया because some of you are asking, you have understood and some of you are doubtful also. हाँ, मैं एक फिर से क्वेश्चन हो देता हूँ आपको अभी पता चल जाएगा. Let's erase this and find the remainder now. What number should I give you? Let's say ऐसा ही नंबर लेते हैं. 2 power 32 is divided by 32. Find the remainder fast. 2 power 32 is to be divided by 32. Find the remainder fast. Ruchika is asking -1 power 91 2 कैसे बना -1 power 91 was -1 -1 3 से रिमाइंडर मतलब 2 है ना -1 raised to power 91 was to be divided by 3 ना so -91 1 raised to power 91 means -1 and -1 remainder with 3 means 2 भाई पॉजिटिव रिमाइंडर करने के लिए हमें उस डिवाइजर को तो ऐड ही करना है ना यस परफेक्टली फाइन दिस इज 0 गुड एक और 2 power 24 divided by 24 fast 2 power 24 divided by 24 चिंतन 1 तो आ ही नहीं सकता it won't be 0 this time now it's 24 okay Hariom says 24 16 okay let's solve it exactly same way as we did earlier so I need to find this remainder so as I said we are not able to cancel out हमें cancel नहीं करना we are not simplifying this we have to find remainder I've just written it like this so what is the highest common factor and the number in the divisor this is only powers of 2 and here we are having 8 into 3 right so 8 is the highest common factor is it fine 8 is the highest common factor among the number and divisor so my remainder is going to be multiple of 8 times remainder of the remaining parts fine now what is the remaining divisor of course it is 3 because 8 we have taken out and what is the remaining number now because I have taken out 3 powers of 2 out so remaining part is 2 power 21 ठीक है ना हाँ 16 आंसर इज करेक्ट अर्नब सो नाउ रिमेनिंग नंबर इज 2 power 21 अब 2 power 21 का 3 से रिमाइंडर कैसे निकालना है इट्स योर चॉइस यू कैन यूज यूलर्स थ्योरम आल्सो सो यूलर्स थ्योरम विल से दैट 2 power 2 will give रिमाइंडर 1 इट्स ट्रू तो 2 power 2 2 power 2 तो 2 power 20 will give रिमाइंडर 1 तो रिमाइंडर इज 2 सो दिस इज फाइनली 8 times 2 that is 16 so this is the right answer Fine. How 24 came here? How 24 came here? ये मैंने दिया था 24 बाबा. That was the question. पिछले क्वेश्चन का तो आंसर 0 था because it is divisible. 32 is 2 power 5 only, that was divisible. But in this case, it is not completely divisible because 24 is 8 into 3. So 8 is the highest common factor among the number and divisor. So we just discussed whenever we are having some common factor, so remainder will be multiple of that highest common factor. So 8 times remainder of the remaining numbers. तो इसमें से भी 8 बाहर निकाल लिया, इसमें से भी 8 बाहर निकाल लिया. That need not to be cancelled out. ये बात ध्यान रखनी है. तो इसे मैंने साथ में लिख लिया उसको. कई बार लोग इसको हटा देते हैं, बाद में मल्टीप्लाई करते हैं. That's okay, that's same thing. So 2 power 21 is the remaining number because 8 has been taken out, and 3 is the remaining divisor because 8 has been taken out. Now ये remainder निकालना आसान काम है. That comes out to be 2. That you have done. Similar questions you have done many times. So final answer is 8 times 2, that is 16. Okay. If M and N are not co-prime, then CRT use करना चाहिए ना. CRT पे मैं next आ रहा हूँ. ठीक है. Let's erase this part. Now, what is the purpose of CRT? See, actual आपको सिर्फ ये CRT का नाम ही सुनने में मिला है. हम actual CRT use करते भी नहीं हैं. But purpose of CRT is that कि the divisor is a large number and it may be co-prime with the divisor. ऐसा जरूरी नहीं है कि उसमें कुछ common factor होना चाहिए. We can use in other ways also. There was one comment, Shweta. Harshita is asking when we have to consider negative remainder and when to consider positive. Whenever it is beneficial, I gave you one example. मैंने 16 का remainder पूछा था 17 के साथ. 16 power 100 का remainder पूछा था. In that case, it is better to use a negative remainder, isn't it? So we'll write it as -1 raised to power 100, which means +1. That's it. We are done. है ना? और अगर suppose अगर मैं आपसे पूछता हूँ, क्या पूछें? 18 raised to power 100. What will be the remainder when this number is divided by 17? It's 1. है ना? अब यहाँ थोड़ा negative remainder use करोगे. In that case, we are going to use positive only. So 18 when divided by 17 gives remainder 1. So basically it is 1 raised to the power 100. That is 1. Finished. It's as simple as that. ठीक है ना? So don't be confused. कुछ रट्टा नहीं मारना है. We are just looking whatever is beneficial at a particular moment. So we should understand the various ways. और जहाँ जो फायदेमंद हो वो हमें चीज यूज करनी है. Okay, let's move further. As I said earlier, we have to cover a lot more things. Okay, so as I was saying about this Chinese remainder theorem now, so purpose of Chinese remainder theorem is to club the remainders with two particular divisors. दो अलग-अलग divisors से कैसे combine उसके remainder को हम कर सकते हैं, that's what we need to find. So let me tell you an example, उससे आपको बात easy समझ में आएगी. Any doubt so far? Can you use CRT when numbers are not co-prime? Co-prime CRT पे आ रहा हूँ बेटा, Vinny. Wait, just have patience, bit patience. So what is CRT? We are not discussing this theorem exactly. This theorem is something else which you are using in groups. I have seen that. So that's not actual CRT. CRT का जो theorem है, जो उसका result है, वो अलग चीज़ है. That's very lengthy. But we are using its purpose. So purpose क्या है? Suppose let me give you an example. क्या example है? Maybe 77 raised to power say 77. I need to find its remainder with 15. Let's say that's a question. ठीक है, 77 raised to power 77. We need to find its remainder with 15. So how we can do it? Can we apply Euler's theorem? Tell me yes or no. Can we apply Euler's theorem here? मीमांसा को लग रहा है नो, बाकी लोग तो यस बोल रहे हैं. अर्क्षिता, अंशिका भी नो बोल रहे हैं. Why no भाई? The condition was number and divisor should have been co-prime and they are. 77 और 15 में कुछ कॉमन दिख रहा है क्या? There is nothing common. 15 is 3 into 5 and 77 is not divisible by 3 nor by 5. So Euler's theorem can be used here. Euler's theorem can be used. ठीक है ना? So both are co-prime. So Euler's theorem can be used. So if I use Euler's theorem, so see 15 is basically 3 into 5. I need to find its Euler's value, phi of 15. So that is going to be 15 into 1 minus 1 by 3, 1 minus 1 by 5. Basically 15 into 2 by 3 into 4 by 5, which means 8. Right? So because highest common factor of 77 and 15 is 1, इनका highest common factor तो 1 है. So as per Euler's theorem, I need to calculate the phi या Euler's value of 15. That comes out to be 8. So according to Euler's theorem, 77 raised to power 8 or any multiple of 8 will give me remainder 1 when divided by this divisor 15. Till this point, is it okay? Right. So I'm using remainder this Euler's theorem right now. Many of you have found the right answer as well. Okay. I don't remember the answer. I need to calculate it. Okay, so now what is the next step? I need to see what is the highest multiple of 8 till this required power. 77 के nearest कौन सा number है? 8 9 is 72, I guess. ठीक है ना? So 77 power 72. That will also give remainder 1. Now remaining power is 77 raised to power 5. Now we need to focus on this part because this is remainder 1. So 1 into 77 power 5. Now we need to find remainder with this. Now what is the next step which we normally do? 77 का 15 से remainder निकालोगे, right? 77 when divided by 15 gives you remainder 2, right? Because 75 is divisible, remainder is 2. So this is 2 raised to power 5. 2 raised to power 5 means 32, and 32 when divided by 15 gives remainder 2. So there was no use of remaining going to Chinese remainder theorem. We just used Euler's theorem only, we got our answer. But now in the same question, we may have used Chinese remainder theorem as well. वो कैसे? Shubhajit is asking something. So 77 more 15 is 2, so 2 power 77, 2 power 4 is 16, wonderful. And 16 more 117 is 1, 7, 15, हाँ, ठीक है 1. So remainder is 2. Yes, perfect. So Shubhajit, that's perfectly fine. Okay, so we have solved this question right now by using Euler's theorem. लास्ट स्टेप कौन पूछ रहे हैं? अरबाज इज आस्किंग अबाउट लास्ट स्टेप. सो लास्ट स्टेप, सी मैंने 77 को एज इट इज रखा था, आई हैव नॉट चेंज इट टिल द लास्ट पॉइंट. सो टिल हियर आई जस्ट यूज यूलर्स थ्योरम व्हिच टेल्स मी दैट 77 पावर 8 और एनी मल्टीपल ऑफ 8 विल गिव रिमाइंडर 1. सो 8 9s आर 72, तो 72 पावर तक भी रिमाइंडर 1 मिलने वाला है. सो आई एम लेफ्ट विद 77 पावर 5, राइट? Now each of 77 when divided by 15 gives remainder 2, right? So it is 2 raised to power 5. Now 2 raised to power 5 means 32, and 32 when divided by 15 gives you remainder 2. That's it. उसको आप स्टार्टिंग में ही इसको 2 लिख लें, that can also be done. That can also be done. स्तुति 2 पावर 5 कैसा है भाई? 77 को 15 से डिवाइड करोगे तो 2 आएगा ना, 2 रिमाइंडर बचेगा ना. When 77 is divided by 15, remainder is 2. So this is 2 raised to power 5, right? Okay, now how to use Euler's theorem, Chinese remainder theorem here? Yes, Yashwadhan, that's perfectly fine. So Chinese remainder theorem tells कि directly 15 से divide क्यों कर रहे हो? Don't divide directly by 15. So Chinese remainder theorem says because this divisor 15 is 3 into 5. Right? This divisor 15 is actually 3 into 5. So 3 से remainder निकाल लो, 5 से निकाल लो, and then club them. That is the purpose of this Chinese remainder theorem. ठीक है? I'm erasing this part and now solve the same question by using this Chinese remainder theorem. Let's understand the process. मैं बाकी चीज को erase कर देता हूँ and let me write the question again. Basically, question was we were to find the remainder. So we were to find the remainder when 77 power क्या लिखा था? 77 is divided by 15. We have to find this remainder, and answer we have already found. Basically, that is 2. We found this answer by using Euler's theorem. Now we are understanding how Chinese remainder theorem works. So Chinese remainder theorem says don't calculate the remainder with 15 directly. You can make its factors. So basically 15 is 3 into 5. So now this Chinese remainder theorem will work when we divide this divisor into its co-prime factors. Basically this 3 and 5 they must be co-prime. इनमें कुछ common factor नहीं होना चाहिए. तो purpose is Chinese remainder theorem says कि 3 से remainder निकाल लो, 5 से निकाल लो. तो इस नंबर को अगर 3 से divide करूंगा, can you tell me what is going to be the remainder? Please tell me 77 power 77. I want to find the remainder with 3. Let me write more 3 here only. क्या आएगा? तो 77 को 3 से divide करते हैं. Let's divide this base number with 3. तो 78 is divisible. Remainder is -1, isn't it? And -1 raised to power 77. That means -1, and that means 2. Fine. Remainder with 3 is 2. Perfect. And तो 3 से remainder पता लग गया 2. And now find the remainder with 5 also. तो 77 power 77. I need to find its remainder with 5 as well. तो 5 से इसको डिवाइड करूंगा तो 77 will give me remainder 2. ठीक है? तो 2 raised to power, ये पावर को भूलना नहीं है. Power is also there. 2 power 77. Now 2 power 77 का 5 से कितना रिमाइंडर आएगा? You can make use of Euler's theorem also, or you can directly find out some power of 2. तो 2 power 4 is 16, right? Euler's also tells कि 5 का तो 4 ही आने वाला है ना. तो 2 power 4 will give remainder 1 basically. So here 2 power 4 is 16. 16 when divided by 5 gives remainder 1. So 4 into 19. तो 19 pairs बन जाएंगे. That makes it total 76 power. Now 1 2 is remaining. So each of these bracketed number gives remainder 1. तो basically remainder is 2. So now CRT बोलता है, Chinese remainder theorem says you have found the remainder with 3, you have found the remainder with 5. Now just club them, combine them. तो 3 से भी remainder 2 दे रहा है, 5 से भी remainder 2 दे रहा है, तो club करने पे क्या आएगा? It is going to 2 only. How to find that? That's what is the purpose of this Chinese remainder theorem. So 15 से भी this remainder is going to be 2. How to find this? क्या ऐसा ही बोल सकते हैं क्या? ये 2 वो 2 तो वो भी 2 है ना? ऐसा क्यों आया? So उसके लिए तरीका क्या है? How to club them? There are various ways now. हाँ ये Tanish, yes, that's perfectly fine. So this is one way using equations. So how to club these two remainders? See, अब हम ये ऐसा इक्वेशन क्यों बना रहे हैं, इस चीज को ध्यान से समझो बात को. I hope till this point it is very clear. There should not be any doubt in this. मैं इसको erase नहीं कर रहा हूँ, ये यहीं पे है. So basically ये जो भी नंबर है, let me write it as n, या 77 power 77 लिखते हैं. 77 power 77. We want to divide it by 15 actually. So there will be some quotient and there will be some remainder. Now what is this remainder we need to find out? We have just found out so far कि 3 से divide करने पे we are getting 2 and 5 से divide करने पे we are getting remainder 2. ठीक है ना? Okay. Now think. When this number is divided by 3, remainder is 2, right? This number means this complete number. So is this term divisible by 3? Yes. So 2 remainder कहाँ से आएगा? R से. So basically R is such a number which when divided by 3 gives remainder 2. Isn't it? R is such a number which when divided by 3 gives remainder 2. मतलब R is of the form multiple of 3 plus 2. R is of this form. Is this fine? Similarly, if I divide this number by 5, my remainder is 2. We have just seen that. ठीक है? तो basically this entire number when divided by 5 gives remainder 2. So this first term is divisible by 5 because 15 is divisible. So that means this R must be that number which when divided by 5 gives remainder 2. मतलब R is also of the form 5b plus 2. Now we just need to find the values of A and B which satisfy this equation and we are done. And obviously A and B both are 0, that satisfies. So the remainder is 2 only. ठीक है? These values may be different also. In that case you need to solve. Otherwise in this case we can find easily. ठीक है? So using trial we can find the values. Right? HCF वाले मेथड का नाम क्या है? नाम क्या होता है उसमें? When the number and divisor are not they are not co-prime, then they are having some common factor. हाँ, स्तुति, yes, Euler is the base method. So, but that is also useful only when we are having some very high powers. If the powers are less, in that case, that is also not to be used much. ठीक है, लेट्स प्रोसीड फर्दर. ठीक है, 2.96 वाले 96 को चाइनीज रेमेडी थ्योरम वंशी नायक हैज पोस्टेड इट 4 times. ओके, ठीक है जी वंशी जी, लेट्स सी इट हियर. हाँ, यस राकेश, आई एम एक्सप्लेनिंग इट वंस मोर बाय यूजिंग द एग्जांपल मेंशन्ड बाय वंशी. आई एम इरेजिंग दिस. सो लेट्स सॉल्व द सेम क्वेश्चन. अगर मुझे 2 power 96, if I want to find remainder of 2.96 with 96, although we had found the answer as 64, let me write it here. We have already found this answer by using the other method. But now, if I want to use Chinese remainder theorem here, now Chinese remainder theorem had no condition that number and divisor should be co-prime. There is no condition. वो क्या बोलता है? It only says that divide this divisor into co-prime factors. So 96 is basically 2 power 5, that is 32 into 3. And 32 and 3, they are co-prime numbers, right? They are not having any common factor. So now what we need to do? We need to find the remainder of this number with both of these numbers individually. ठीक है ना? So 2 power 96 when divided by 32, can you tell me what will be the remainder? When this 2 power 96 is divided by 32, what will be the remainder? Exactly, Ishani, that's a wonderful statement. Thanks for that. So 2 power 96 is divisible by 32. We had seen that earlier when we were taking out the common factor. Right now we are going to use Chinese remainder theorem. So this remainder is 0. ठीक है ना? Here the remainder is 0. Now the next step, 32 से remainder मिल गया, it is 0. And 3 से when we divide this number 2.96 with the other part of our divisor 3, तब कितना remainder आएगा? Now 2 power 4 gives remainder, 2 power 2 square is 4. So 2 square 4 gives remainder 1. Basically 2 square, if I break this number in powers of 2 only, so there will be 48 pairs, 48 groups, and 2 square, that is 4, and 4 when divided by 3 gives remainder 1. So basically this remainder is 1. ठीक है ना? तो we have got the remainder of this number when it is divided by both of the factors. ठीक है? Now Chinese remainder theorem में condition क्या है? The groups, the divisor when we are dividing it into numbers, they must be co-prime. इनमें कुछ common factor नहीं होना चाहिए. Okay, now I think वापस में बातें बहुत सही चल रही हैं. Anyway, so now how to club them? As I wrote earlier, so by method of equations, as you were doing, so we can do that. So this is 32a, remainder is of the form 32a, क्योंकि 32 का multiple होना चाहिए, and 3 से remainder 1 होना चाहिए. That means 3b plus 1. Now see what value you can put for the b so that this term becomes multiple of 32. So what can be the value of b here? It will be 21, right? If I take b to be 21, so 21 times 3 is 63, and plus 1 makes it 64. Yes. Is it fine? So you'll take b equals 21. So 21 times 3 is 63 plus 1, that is 64. So that is our remainder. So you have solved the same question using Chinese remainder theorem as well. Is it okay? Dhruv is asking if we divide 96 by 3, it will give 0. 96 को थोड़ी divide करना है भाई, हमारा number ये है ना. Our number is 2 power 96. We need to divide this number by the divisors. वो तो 96 के तो factor किए हैं, उसको क्यों divide करेंगे? Swasti is asking why is Euler not applicable to known co-prime dividends and divisor? वो तो Euler बता सकता है. We are using that theorem. हाँ, क्लबिंग वाला बता दो दोनों रिमाइंडर्स को. हाँ, क्लबिंग के लिए राइट नाउ वी हैव यूज्ड द इक्वेशन मेथड. 32 से रिमाइंडर 0, राइट, एंड 3 से रिमाइंडर 1. सो वी नीड टू क्लब देम नाउ. तो क्लब करने के लिए हमें क्या करना है? वी नीड टू फाइंड द वैल्यूज ऑफ a एंड b व्हिच सैटिस्फाई दिस इक्वेशन. सो इन दिस केस a की वैल्यू कुछ भी पुट करूं, दिस इज गोइंग टू रिमेन मल्टीपल ऑफ 32, राइट? तो क्या हम इस नंबर को 32 बना सकते हैं क्या? लेट्स चेक. अगर मैं इसको 32 बनाने की कोशिश करता हूं तो 3b plus 1 if it is 32, so 3b should be 31. It is not possible because b must be an integer here, right? So this is not possible. Next case, इसको 64 बनाएं तो 3b plus 1, can it be 64? Yes, क्योंकि 3b will be 63 and b comes out to be 21 as we had already taken. So we are just taking the values which will help it. ठीक है ना? Okay, so using these equations, that is one of the ways to club. And to club, there are other methods also. To club these remainders, there are other methods also. This equation is not the only method. Sometimes this hit and trial with some values may be tedious. ठीक है ना? So let's understand that also. If without making equations, how we can club these remainders? Let's understand that also. Let me create some space here. So this equations was one of the methods. Now other method was just directly work with the numbers. Just directly work with the numbers. Now see how. Bhaskar, how 0, which how 0 bhai? 2 power 96, 32, 0. ये वाला 0. 32 is 2 power 5. 2 power 96, 2 power 5 से divisible नहीं है क्या? It is divisible ना? That's why it is 0. Okay, I hope there is no doubt here. Kanishk is saying something. Acha, he is answering. Alicia is answering. Okay. Aditya, we have done that question. That's homework for you. Right now, understand the method of clubbing. So for clubbing, so far we have used the equation method. ठीक है? The other way is to work directly with numbers. इसका क्या मतलब है? Now please be focused here and answer my questions. हाँ, इक्वेशन क्लबिंग तो भी मैंने बताया था आनंदो कि वी आर राइटिंग, वी आर चेकिंग वैल्यूज एंड दिस विल बी बेटर मेथड. ये आपको ज्यादा पसंद आएगा. सुनो ध्यान से, देखो जरा क्या है. सी, आवर रिमाइंडर इज गोइंग टू बी अ नंबर व्हिच सैटिस्फाई बोथ ऑफ दीस कंडीशंस कि 32 से रिमाइंडर 0 देना चाहिए और 3 से डिवाइड करने पर रिमाइंडर 1 देना चाहिए, राइट? दैट इज द थिंग. नाउ एज आई एम सेइंग कि इन प्लेस ऑफ equation, let's directly work with numbers. How I can do that? See, 32 से 0 रिमाइंडर देने वाला smallest number is 0 only. जो 32 से डिवाइड करने पे 0 रिमाइंडर देगा, राइट? What can be the next number? Can you tell me what is the next number जो कि 32 से डिवाइड करने पे 0 रिमाइंडर देता है? Please tell me what is the next number greater than 0 जो 32 से डिवाइड करने पे 0 रिमाइंडर देता है? What is the next number which gives remainder 0 when divided by 32? 64 is okay, but 64 से पहले कार्तिक not 12. I want remainder 0 with 32. 32 से डिवाइड करने पे 0 remainder. Yes, perfectly fine. 32. Right. So 32 also gives remainder 0 when divided by 32. Then 64 also is the number which gives remainder 0. Then 96 will also be a number, and so on. Right. There are many numbers. Is it fine? Is it fine so far? Right. So 0, 32, 64, 96, and so on. There are many numbers which satisfy this condition. Okay, but now I not only need to satisfy this condition only, I need to get satisfied with this condition as well. I need to make this condition also satisfy, right? तो हाँ 32 का टेबल बन गया, वो चांस की बात है because remainder 0 था, and it may be something else also. But whatever it be, we can always find the next possible values. Now we need to see कि 3 से डिवाइड करने पे remainder 1 भी आना चाहिए, right? 3 से डिवाइड करने पे when we divide this number with 3, remainder should be 1 also. Let's see, इसको 3 से डिवाइड करेंगे तो क्या remainder आएगा? It is 0 only. It doesn't say 1. यहाँ पे 3 से डिवाइड करेंगे तो remainder will be 2, और यहाँ पर 3 से डिवाइड करेंगे तो 1. It satisfies. That's our answer. Isn't it simple? That's how, just by working with numbers, we can club these remainders very easily. Is it okay? Thank you. हाँ, सिंचन फैक्टोरियल वाले रिमाइंडर भी हमें करना है. That's what I'm saying. There are too many things we have to cover today. But if you don't understand, then कोई फायदा नहीं है ना. That's why my objective is that you must understand the things very clearly. बहुत बहुत धन्यवाद. Okay. Let's practice this clubbing once more. हाँ श्रेया, yes, I understood. तो so far we have seen two methods of clubbing the different remainders. Purpose of using Chinese remainder theorem is to club the remainders only. और वो क्यों करना है? Chinese remainder theorem बोल रहा है कि directly बड़े divisor से क्यों divide करते हो? You can break it in smaller part and then club them. That's what Chinese remainder theorem says. And how to club them? We have seen two methods. One was using equations, and another is working with numbers. I'm taking some more examples so that you become more practiced. हाँ, मैं भी example दे रहा हूँ मुझे. Let's see. हाँ, yes, one more question. Okay, let me erase it. And there are many things to cover. I'm just on first slide here. Okay, now I'm not giving a large number, I'm directly giving a value. Let's say there is a number which when divided by 3, say it gives remainder 1, okay? And the same number when divided by maybe 7 gives remainder, let's say 3. मान लेते हैं ऐसे. So question is, what will be the remainder when the same number is divided by 21? So these types of questions also we can find in exam. I repeat, there is a number which when divided by 3 leaves 1 as the remainder. There is a number, the same number, which when divided by 7 leaves remainder 3. So what will be the remainder when the same number is divided by 21? Okay, I started getting the answers. 3, 10, 3, 10, 10, 10, 10, 10, 10. We need to find the remainder with 21. Okay. I think still many of you are doing it. See, I have said this earlier also, when we are finding the remainder as answer, so answer will always be a positive value or no negative value. It may be 0 sometimes, but it can never be negative. So for answer purpose, don't write the remainder as negative ever. हाँ, कशिश negative remainder नहीं लिखना है आंसर में. While solving, we can use negative remainder wherever it is beneficial. Okay, सभी लोग 10 का दम भी बोल रहे हैं. Okay. ठीक है, let's see how to do. कौन सा मेथड यूज किया आपको बताओ ना. What you have used? Equations or numbers? Write in the comments. Most of you are saying 10 now, and I can see that 10 satisfies. Yes, 10 is the right answer. What method have you used? Equations or directly work with numbers? What have you done? Write in comments. अरे वाह, हाँ दिमाग सिर्फ तो मतलब numbers ही ना, right? Equation भी use किया कुछ नहीं, good. Okay, if I make equations, so how to solve it? By using equations means my remainder is going to be of the form 3a plus 1. My remainder is going to be of this form, multiple of 3 plus 1. We get to know from here. And from here, I got to know that multiple of 7 plus 3, that is 7b plus 3. Now, we need to find out certain integers a and b which satisfy this. ठीक है ना? So what will satisfy? If I check here, if I put b equals to 1, so 7 plus 3, 10. 10 satisfy this also. Done. You know? So we can solve it very easily. We are just checking the values here. So here we are checking what certain values which will work. ठीक है? The other way we just discussed, work with numbers. Same thing. We are writing in form of algebraical equation. We can directly write in terms of numbers. So when we are writing numbers, it would be better. Can you think कि कौन से number लिखना better रहेगा? 3 से remainder देने वाले या 7 से remainder देने वाले? It will always be easy to write the remainders with the larger divisor. So 3 is the smallest number which gives remainder 3, which satisfies this condition. The next number which satisfies this condition is going to be plus 7. That is 10. The next plus 7, 17. The next plus 7. And so on. So these are all various numbers which gives remainder 3 when divided by 7, right? नाउ आई जस्ट नीड टू चेक कि इस कंडीशन को सेटिस्फाई करने वाला इनमें से कौन सा नंबर है, राइट? स्मॉलेस्ट नंबर आई एम लुकिंग फॉर. सो 3 डज नॉट गिव इट रिमाइंडर 1. 3 when divided by 3 will leave remainder 0, but 10 when divided by 3 will leave remainder 1 as required. So this 10 is the answer, right? So you have learned about the methods. I hope that's easy, that's not difficult. Is it fine? You understood how to apply, when to apply, and one particular question can be solved in various ways. Okay, let's move further then. ठीक है? So here's one question for all of you. Please answer this fast and try to use Chinese remainder theorem. It's up to you. अरे वो 21 से रिमाइंडर निकाला ना, लास्ट पार्ट वही तो था. Those who are not clear about the last question, don't worry, answer this one. It will be covered here. Same thing. I guess it's very easy. There's no need to use any remainder theorem. Directly, you can subtract 91 from this. You can directly divide by 91 only. But this question will become better. Maybe if I use some power also here, maybe 115 raised to power 60 is divided by 91. Now try to answer it. 21 was the right answer for the last question. I have just updated the question. This question is 115 raised to power 60. Now try to answer it. हाँ शिंचन, ये वाला क्वेश्चन पक्का कैट में आ सकता है जो अभी मैंने अपडेट किया है. This question is certainly CAT level. क्योंकि CAT में easy question आते हैं. As I said earlier, CAT does not expect you to know any remainder theorems. Shruti, try to find on your own. We'll discuss it. Don't worry. Okay, many of you are writing one. Chinmay is asking. बता रही हो कि पूछ रही हो चिन्मयी? क्वेश्चन मार्क लगाया है आपने. Okay, what is the right answer? What is the method? Please write the method also. What method have you used? Bhaskar is saying 7x is 13y. ये 7 से divisible था क्या? अच्छा, दोनों में same remainder आया I guess. CRT, okay, CRT. Shruti, I tried but my answer is not matching. अरे मैच कैसे करना है? हमें एग्जाम में आंसर की थोड़ा मिलने वाली है. We just need to confirm on our own. Are you sure whether the method applied by you is correct? If you are doubting, then recheck. Okay, many of you applied CRT with 17 and 3. Okay, CRT had no condition. We just need to see the divisor. This 91 is the divisor. I need to break it in its co-prime factors. It is 13 into 7. ठीक है ना? So Chinese remainder theorem says find out the remainder of this number individually with both the divisors, then club them, right? So हाँ ठीक है, मैं समझ गया. 13x is equal to 7y लास्ट में आया. I got it. Okay. So 13 से रिमाइंडर निकालना है, 7 से निकालना है. और if some one of you think कि डायरेक्टली निकाल लेते हैं 91 से, तो डायरेक्टली भी कर सकते थे. That's fine. Because 115 is not divisible by 7 and not divisible by 13 as well. So Euler's theorem use करें directly. That could also be done. But anyway, 13 से रिमाइंडर निकालते हैं. So 115 raised to power 60. I need to find its remainder with 13. So what will you prefer? What method will you use to find this remainder? Euler's, of course, है ना? Because directly मुझे पता नहीं किससे रिमाइंडर देगा, क्या देगा. I can look for the powers. और otherwise 115 को 13 से डिवाइड करेंगे, कितना रिमाइंडर आएगा? 1 तो नहीं आने वाला है. Let's use Euler's only. Euler's says because 13 is a prime number, तो 12th power will give remainder 1, right? 12th power will give remainder 1 because 13 itself is a prime number. So 12th power will give remainder 1. So 60th power will also give remainder 1. ठीक है ना? अच्छी बात है. यू आर सेइंग -2 रिमाइंडर फॉर दिस वन. 13 से डिवाइड करेंगे तो, बट दैट्स नॉट रिक्वायर्ड. पहले पावर से डील कर लेते हैं. तो हियर पावर इज 60. सो यूजिंग यूलर्स थ्योरम, 13 का 5 या यूलर नंबर बनेगा 12 एंड दिस पावर इज मल्टीपल ऑफ 12. तो दिस रिमाइंडर इज 1. ठीक है, दिस रिमाइंडर इज 1. Finished. And remainder with 7, 115 raised to power 60 mod 7. Again we can make use of Euler's theorem, right? Because 7 का 5 is 6 and this is again multiple of 6. Again remainder 1. जब दोनों का remainder same ही है तो this is a common number. Finished. So 1 is the right answer here. That's club. अब इसको equation लिखना है तो we could have written 13x plus 1. It must be equal to 7y plus 1. So remainder is going to be of this form, which is obviously put x 0, then y is also 0. Remainder is 1. ठीक है. और if you are looking for the common numbers, in that case this 1 is a common number. That's it. 1 satisfies. Directly Euler से solve करेंगे तो in that case we need to find the Euler value of 91. So Euler value of 91 कैसे निकालें? That is going to be 91 into 1 minus 1 by 13, 1 minus 1 by 7, which is 91 into 12 by 13 into 6 by 7, right? So 13 sevens are 91 and 12 sixes are 72. तो यूलर थ्योरम तो कुछ नहीं बता रहा है यहाँ पे, बिकॉज यूलर के अकॉर्डिंग 72nd पावर विल गिव रिमाइंडर 1, बट इट डज नॉट टेल अस अबाउट द लोअर पावर्स. तो यूलर इज नॉट गोइंग टू बी वेरी हेल्पफुल डायरेक्टली, राइट? इज इट अंडरस्टूड? ठीक है. अच्छा, लेकिन नाउ अंडरस्टैंड, लेट्स क्लब ऑल दिस थिंग. यूलर को भी ले लेते हैं. सी, व्हाइल यूजिंग चाइनीज रिमाइंडर थ्योरम, द सीआरटी, दिस क्लबिंग प्रोसेस, अगेन वी हैड यूज्ड यूलर थ्योरम हियर ना. यहां भी तो हमने यूलर यूज किया ही है. चिंतन ब्रेक, आई वोंट प्रेफर टू हैव ब्रेक. अभी तो थोड़ा सा स्मूथ फ्लो बना है ना. इफ यू वांट टू टेक 2 minutes 5 minutes ब्रेक, यू कैन गो, नो प्रॉब्लम. हाँ, यस, यू कैन टेक. आई विश लाइक टू कंटिन्यू. सी, इस प्रोसेस को सॉल्व करने में भी वी हैव यूज्ड यूलर थ्योरम. सो लेट्स क्लब बोथ द थिंग्स टुगेदर. लेट्स क्लब बोथ द थिंग्स टुगेदर. अरे फिर से साइड टॉक्स, प्लीज कम बैक. लीव इट. सो using Euler's theorem, we got to know that this number 13 से कौन सी पावर रिमाइंडर 1 देंगी? When we are dividing by 13, तो Euler value of 13 was 12. So basically, when this number is raised to power 12, when this power is basically multiple of 12, then remainder is going to be 1, isn't it? Remainder answer we have got, beta, it's 1. Answer is 1. We have already found that. We have used this CRT. We have found the individual remainders with 13 and 7, and then we have clubbed them. We have clubbed them using the equation method or directly the common number method also. But now I'm saying, if you are using Euler's number directly here, so that the Euler number was coming out to be 72. So 72 could not be used here because 72 is a higher number than 60. ठीक है ना? But 72 is not necessarily the smallest power which gives remainder 1. There can be smaller powers than this one. ठीक है? तो how to find that? See here now what I'm saying. ये 13 से when you are dividing, तो 12th power or any multiple of 12th power will give remainder 1. Is that fine? These side comments or unnecessary comments are very boring actually. (24 power 60). Yes, we can write 24 per 60 also. There's no issue. But उससे benefit क्या है? उससे कुछ benefit नहीं है ना. Okay, now see here. So 13 से जब हम divide कर रहे हैं, the power must be multiple of 12, right? And इसी number को, when the same number is divided by 7, then which power will give remainder 1? When the power is multiple of 6. Basically, a Euler value of 13 and Euler value of 7. So basically, when power is multiple of 12, I will get remainder with 13 as 1. When the power is multiple of 6, then I'm going to get remainder with 7 as 1. Can you tell me the common power? When power is multiple of both of them, that is their least common multiple. When the power is multiple of 12 as well as multiple of 6, that is when the power is multiple of 12. Yeah, basically power is 12. Yes. So when power is 12 or multiple of 12, it is going to give remainder 1 with 13 as well as 1 with 7 also. So basically, in spite of 72, directly I have found that 12 is that power of this number which will give remainder 1 when divided by 91. So directly we can use it also. ठीक है ना? तो यूलर्स वाले में जो दिक्कत आ रही थी यहाँ पे, द प्रॉब्लम विच वी आर फेसिंग हियर 72, उसको हमने छोटा कर लिया है. तो 72 से कम, द स्मॉलर पावर 12 इज आल्सो देयर, व्हिच इज रेज्ड टू दिस नंबर व्हेन 115 इज रेज्ड टू पावर 12, दैट विल आल्सो गिव रिमाइंडर 1. ठीक है? ये यूलर फेल नहीं हुआ है, यूलर का हमने बेटर यूज किया है यहाँ पे. वी हैव यूज्ड इट इन द बेटर वे. ओके, लेट्स मूव फर्दर नाउ टू सॉल्व सम मोर क्वेश्चंस. सो हियर इज द नेक्स्ट क्वेश्चन, एंड दोज हु वांट टू टेक अ ब्रेक, यू कैन टेक अ ब्रेक इन दिस क्वेश्चन. And others, please continue. Find the answer. Find what is the remainder when 2 power 80 is divided by 119. This is the last question based on this part, and then we will move to the next topic. Which method will you prefer here? Let's solve it again together. Many of you are still mixing up the things because of this unnecessary other talks. Which method will you prefer here? Bhaskar, in the last question answer was 1. 17 into 7, yes. अगर directly 119 से भी निकालना है, तो it's better to see that 119 is 17 into 7. And certainly it is co-prime. Right, now using CRT, we are to find the remainder with 17 and then with 7. But before that, as we just did in the last question, what power of this number 2 will give remainder 1 with 17? 17 से क्या power आएगी? Euler number of 17 is 16, right? And Euler number of 6 is, Euler number of 7 is 6. Right? So whenever power is multiple of 17, I will get remainder 1 when divided by 17. ठीक है ना? And whenever this power is multiple of 6, in that case, remainder will be 1 when it is divided by 7. So let's work together. We will use CRT later. So when power is multiple of both 16 and 6, so number which is multiple of 16 as well as 6, what is that? What is the number common multiple of 16 as well as 6? That is their lowest common multiple or LCM. It's 48, right? तो 48 पे और तक तो खत्म हो गई बात. If this power had been multiple of 48 या उसके आसपास कहीं होती तो very easy, it would have become much easier. But anyway, अभी तो ये उसके आसपास है नहीं, power will be remaining, 32 power will be there. So we need to go individually only, ना directly find out tonight, maybe tedious task. We need to go individually. Okay, so basically from here we have got to know that 2 raised to power 48 or multiple of 48 will give remainder 1 when divided by 119. So that's the thing which we were discussing in the last question, right? But it is not very easy to apply it here because not much benefit we are getting. Okay, so let's find out the individual remainders with 17 and 7. So 2 power 80 when divided by 17. What will be the remainder? So 16 के ग्रुप बनाने होंगे, right? 16 के ग्रुप बनाएंगे तो 80 is multiple of 16. And that gives you remainder 1 because 2 power 16 gives remainder 1 with 17. This was 17. So from 17 we have got the remainder as 1. And with 7, you know that 2 cube gives remainder 1. 2 cube is 8. So 2 power 3 is 8, which gives remainder 1 with 7. So 2 power 3 वाले groups बनेंगे 78 तक. That means 26 groups. 78 power is used. Now 2 square is remaining. That is 4. Because this is 1. 2 power 3 is 8. That gives remainder 1. So basically from 7 we got the remainder as 4. So now we have to look for that number which satisfy both of these conditions. Right? Just we need to club that. So if you're writing answer as 67. Okay, let's see. So we can make use of equations. If I write equation, so it will be 17a plus 1. Remainder should be of this form, or 7b plus 4. ठीक है ना? So now we can check the values. So if you put what? If I put a equals 1, will it satisfy? What value will satisfy here? We have to find the values of a and b which will satisfy this. A and b are integers. I think a equals to 1 satisfies, isn't it? Yes, 18 is the right answer. Just put a equals to 1. If I put a equals to 1, that is 17 plus 1, that is 18. And 18 satisfies this if I put b equals to 2. 7 into 14 plus 4. So 18 is the right answer here. Okay, that is using equations. Or if we are directly working with numbers, so I would prefer to write the numbers with the higher divisor, larger divisor. So 1 was the smallest number which satisfies this. The next will be 1 plus 17, that is 18. And 18 satisfies this condition. When it is divided by 7, the remainder is 4. So this 18 is the right answer. Okay, na? That's what we have discussed everything. So I hope there should not be any confusion now because we have solved many questions. Same thing we have repeated in various questions. Okay, let's proceed further. Now I'm leaving this question. You can note down this question. You can answer me later. 72851. Or you please try to answer it quickly. I'm giving you 2 minutes for this. Please try to answer this fast. Method is up to you, whatever way you want to use. Diksha CRT से तो किया हमने पिछला क्वेश्चन ना? हाँ, yes, I wish to move to the next topic now. We need to do many other things. Vyom, we have not discussed any shortcut. What shortcut? We are using the methods. Please try to solve this one now. Ishani, if you are unable to solve the equations, then we have discussed the method of the numbers also. It will be easier. Actually, both are same things. So think in terms of numbers if you are unable to think in terms of variables. Yes, Vyom, regarding clubbing numbers, we work with clubbing the remainders. We discussed 2 methods. One is with equations, where again we are checking the numbers, or the other thing was working with numbers directly. So number methods se karo. Yes, that's why I have told you. In equations also we are working with numbers only. We are thinking what number will satisfy. Rudra, last step of previous question, how 24 remainder came? Let's see the one. 24 किसमें आया था? Let me check. Where's 24? कौन से क्वेश्चन पे हो भाई? पिछले 2 क्वेश्चन में तो 24 नहीं था. Anyway, right now do this. Gunjan mode 7 repeat कर दो. 7 से remainder हमने निकाला था ना Gunjan. 2 cube was giving remainder 1. In the last question we did that 2 power 3 when divided by 7 gives remainder 1. Right? So we just use that part. So we made groups of 3 powers of 2. Okay, in this question answer, when you were writing answer 35, some of you are saying 27. Joy says 23. Okay, let's solve it. We are getting different answers. Let's solve it. So we need to find the remainder with 36. Of course, we would prefer to go by CRT, by dividing this divisor into 2 co-prime factors, that is 4 and 9, right? Okay, na? So, किससे remainder पहले निकालें? It's your choice. Let's work with 4. So if I find the remainder of this number with 4, so can you first tell me what will be the remainder of this base number when divided by 4? I just need to see the last 2 digits, that is 51. So 51 when divided by 4, remainder is 72851 raised to power 219. So first I'm dividing this base number with 4. What will be the remainder? Mode 4 first we are doing. So I just need to divide this last two, and it is 51. So 51 when divided by 4, remainder is 3. Or I can use minus 1 also here. Isn't it? That will be better. So this is minus 1 raised to power 219, which means minus 1 and which means 3. Is it fine? Last timing is up to 9. Abhay? Right, so from 4 we have found the remainder. Now we need to find the remainder of this number with 9. So 72851 raised to power 219. I need to find its remainder with 9. So to find remainder with 9, again first find the remainder of this base number. That comes out to be 5, right? Because 7 plus 2, 9, 8 plus 1, 9, remaining is 5. So this is 5 raised to power 219. Okay? Now, can you find out by using Euler's or any other way, what is the smallest power of 5 which gives you remainder 1 when divided by 9? Simran Singh is asking how 3. अरे भाई minus 1 remainder with 4 का मतलब 3. क्यों आया? See, yes 4 minus 1. Thank you Samishta. See, how did we got minus 1? यहाँ पे minus 1 क्यों नहीं पूछा? ये minus 1 को 3 पूछ रहे हैं यहाँ. तो you should ask this also. ये minus 1 आया ही कैसे? So we are subtracting 4 repeatedly from this and we have got minus 1. Many of you are saying 3 also. है ना? So basically we are making the remainder negative or positive. How? By adding or subtracting the divisor. So in this case divisor was 4. तो 4 से remainder हमने निकाला था तो 3 या minus 1. Same way minus 1 मतलब 3 by adding the divisor. 5 से कितनी पावर पे रिमाइंडर बनाएगा? 5 या यूलर वैल्यू इज 6 here ना, 5 power 6. So 5 power 216 तक exactly. So basically 5 power 6 gives you remainder 1 with 9 because of Euler's theorem we can say, and 6 के multiples कहाँ तक बन जाएंगे? 216 तक. Basically 36 those बन गए and remaining is how much? 5 power 3. Now 5 power 3 again gives remainder minus 1. 5 power 3 gives remainder minus 1. 5 power 3 is 125. 125 means 5 to 7 and 1 8 gives remainder minus 1, which is basically 8. This time it is 8 because the divisor was 9. ठीक है ना? Okay. Answer is not 23 Remjum. See, now how will you club them? Till this point I guess it is okay, right? यहाँ तक कोई doubt नहीं है ना? Can we use negative remainder in the equation? Yes, why not? Negative remainders can be used everywhere except the answer. Except the answer. Now tell me next step. यहाँ तक की बात सभी clear? 5 power 6 can be how 5 power 6 came कोई? अरे बाबा 9 से remainder 1 कैसे आएगा? If I am using Euler's value, Euler's theorem, तो what is the Euler value of 9? Can you calculate Euler value of 9? 9 is 3 square, na? So it is 9 into 1 minus 1 by 3. That is 9 into 2 by 3. That is 6. That is Euler's theorem only. 9 में minus 1 कैसे आया? See, 5 cube is the remaining part, na? 5 cube is 125. If you divide 125 by 9, what will be the remainder? Can you tell please? Okay, Ashar. So one way is to use 3 and 8 and make equations and club them. So 9 से remainder इसका 8 आया. 8 means minus 1. That's why I have written minus 1 here first. So 8 can be said as minus 1 also, na? Anyhow, so I work with smaller numbers. I prefer to work with smaller numbers. Minus 1 is a smaller number. That's why I wrote it. And then I wrote 8. It's okay if I want to write positive value. Now I can make equation. That is one of the ways. Now I can make equation with 3 and 8. So you will write this 4a plus 3 equals to this 9b plus 8. That is one of the ways. But some of you ask this very nice question in the comments. Can we use negative remainder in the equation? Yes. Yes. So why don't we use negative remainder? That is better. If I use the negative remainder in the equation, so basically 4a minus 1 equals 9b minus 1. Isn't it? So b equals 0 will satisfy, or a and b both equals 0 will satisfy. So remainder is basically minus 1. So when divided with 36, remainder is minus 1. That is answer is 35. ठीक है? और from here also, if I'm clubbing the remainders, अगर दोनों से remainder same ही आ रहा है, here we can see this is minus 1, this is minus 1, तो उससे भी minus 1, यहाँ से भी minus 1, so the common number is minus 1 ना? So minus 1 is the remainder, that is 35. ठीक है? So basically, as I said earlier also, purpose of this CRT is to club the remainders. So how to club the remainders? These are the various ways. So we can make equations, we can just look for the common numbers, and we can use negative remainder also. The purpose is to make the thing easy and simple. So don't be confused anywhere. We have discussed many questions. Certainly you are listening to that for a long time. Now you need to apply them on your own. Let's move further. We have many more topics to cover. Don't worry, you are going to practice these questions, many questions in your application classes as well, application classes and practice classes. Let's move further now. We have to cover many more things. So I'm leaving it now here. So let's move to the next topic for the day. So basic rules of remainders, everything we have discussed. And there's one more variety of remainders which I wish to discuss. Now see that sometimes we have numbers of this format: a power n. Let me first take the negative one. These are some of the properties you should directly remember. You can make a note of that. So a power n minus b power n is always divisible by a minus b. Okay? You need to always remember this and use it wherever you find this. A power n minus b power n is divisible by a minus b. Okay? That's one thing. So A, B क्या numbers हैं? A and B, A, B, N, all are natural numbers here. A, B, N, all are natural numbers here. ठीक है? We are not going for the derivation part. So there are some of the important properties which we are listing here. For example, now, example is very easy. If I put N equals to 1, then it is clearly divisible by A minus B, right? If I put N equals to 1, it is divisible. Say for example, I asked you 77 raised to power 33 minus maybe 33 raised to power 33. What will be the remainder when this number is divided by, let's say 4? What will be the remainder when this number is divided by 4? So although we can find the individual remainders, I want to find what will be the remainder when this number is divided by 4. Yes, it is 0. So one way is to calculate the individual remainders, then find the answer. Or if I'm using this property here, so I can see that this number, this is exactly of this format, right? N is the power, which is same here, and here these are A and B, all are natural numbers. So that means this is certainly divisible by 77 minus 33, which is 44. So जो number 44 से divisible है, तो 4 से भी है ना? So directly answer is 0, right? So this is one very important property. The next step. This A power N minus B power N, this is also divisible by A plus B if N is even. Of course, they all are natural numbers. In addition, this N, this power must be even. So if this power is even, in that case, this expression is also divisible by A plus B. ठीक है ना? So example for this, let's take, अगर आपसे पूछा जाए, यही मैं नंबर ऐसा लेता हूँ, let's say I'm writing it here, 77 raised to power 32 minus क्या नंबर या कुछ और लेते हैं 31 raised to power 32. ठीक है? Now question is what will be the remainder when this expression is divided by 99? Now it's a bit tricky. Try to answer this. Exactly, Siddharth. A square minus B square is equal to A plus B minus B. तो याद रखना बड़ा आसान है. If n is even, so just check the smaller value. If I put 2 only, A square minus B square is divisible by A plus B also. So now answer this. 77 power 32 minus 31 power 32. What will be the remainder when this number is divided by 99? I think I've done some mistake. Let me check it. हाँ थोड़ा सा गड़बड़ किया मैंने भैया. रुको, let me change. I'm changing the divisor. Wait. I'm changing the divisor. I'm increasing the value. It's 621. Now it's a very large divisor now, 621. First try to factorize. The first hint, try to factorize 621. Try to factorize 621. Yes, exactly, Shashank, good. It's 23 to 27. So 621 equals to 23 into 27. That's what we want to find out, right? Okay, now using these properties we have just discussed, this expression is certainly divisible by 77 plus 31, that is 108, which is 27 into 4. That means this sum is divisible by 27, right? This expression is divisible by 27. Is this fine? Next step. I also know that this expression is also divisible by 77 minus 31. How much is 77 minus 31? That is 46. Isn't it? And 46 means 23 into 2. That means this is also divisible by 23. So it is divisible by both. Answer is 0. Understood? So these properties are very simple in their appearance, but they have great significance. Understood? Okay, let's move quickly. There's 2-3 more things. Okay, so far we have discussed about A power n minus B power n. So it is divisible by A minus B always, where A, B, N are natural numbers. And we have discussed the second property, that this is divisible by A plus B also if n is even. Okay, next property now, the third thing. So A power n plus B power n. Now it is plus sign in between. So answer was 0 in that case. कौन पूछ रहा है चिंतन? आंसर 0 है ना बेटा. ये 23 से भी divisible है, 27 से भी divisible है. हाँ नोट कर लीजिए आर्य सिंह. Okay, let's move further. Now next property is A power n plus B power n is divisible by A plus B. ये A power n plus B power n is divisible by A plus B if when n is odd. I repeat, you can easily check again. So अगर n की वैल्यू 1 लेंगे तो it is divisible by a plus b. But if I take n is equal to 2, then a square plus b square is not divisible by plus b. हाँ चिन्मय 99 वाला लेंदी हो जाएगा ना, 99 वाला क्वेश्चन लेंदी हो जाएगा. So that's why I left that. एग्जाम में वो क्वेश्चन नहीं आते हैं. I told you earlier कि एग्जाम में क्वेश्चन लॉजिकल आते हैं, which can be solved very easily and by basic things, by using the basic things. Okay, so a power n plus b power n is divisible by a plus b when n is odd. So this will not be divisible by a plus b अगर n even है तो even के केस में नहीं होगा. Let's take an example. Say if it is क्वेश्चन पूछ रहा है 77, is it visible? I hope so. 77 power 2025 plus 23 raised to power 2025. Question is find the last two digits of this number is equal to. Find out the answer. Find last two digits of 77 power 2025 plus 23 power 2025. Wonderful. Most of you have understood. And with this, I have tried to introduce the next topic also, which we are going to discuss after this, how to find the last digits and all. Yes, 00 is the right answer. See, if I got confused in this, अरे हमें तो last two digits निकालना सिखाया ही नहीं है, so don't bother about that. So what we know by using that, we know that this expression 77 power 2025 plus 23 power 2025, because the power is odd and we are having a plus sign in between, this is exactly divisible by 77 plus 23, which is 100. That means this number is multiple of 100, so certainly the last two digits are going to be 00, which many of you have found it nicely. Good. Good, wonderful. So I hope this property is also clear to all of you. And one last property, this is the last thing which we have written, it can be extended also. First, let me create some space. यहाँ पे थोड़ा सा messy सा हो गया है. Okay, no problem. I will write here only. So this last property which we have just discussed, so we can extend this. This property is extendable if there are more terms, more than 2. So I'm writing it here. So a power n plus b power n plus c power n plus d power n and so on. Any number of terms may be there. That sum is also divisible by a plus b plus c plus d and so on. This will also be applicable. Kab? The same condition that n must be odd. And one extra condition is that these base numbers a, b, c, d and all, they must be in AP. They must follow AP. And what's that AP? AP means the difference between them consecutively is same. Yes, AP means that they are having equal gap. Let's take an example. So AP का मतलब होता है कि when the consecutive numbers are at equal gap. So for example, if I'm having say 7 power 19 plus 9 power 19 plus 11 power 19, what will be the remainder? या एक और भी ले लेते हैं, plus maybe 13 power 19. What will be the remainder when this sum is divided by say 40? Yes, again it is 0. See, if I do not use this property, or if I'm not aware about this, in that case also we can solve it, but then it is going to take a long time. We need to find the individual remainders and then we need to add them and go on. But by using this property, we can directly see that all these base numbers are following arithmetic progression. They're having equal gap. 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13. They're having equal gap. And all of their powers is same and that power is odd also. Right? So using this property, what we get, that this expression is certainly divisible by sum of all of these base numbers. So 7 plus 13 was 20, 9 plus 11 was 20, so 20 plus 20, 40. So this is certainly divisible by 40. Right? So AP है because difference is 2 नहीं मीमांसा, because difference is same. Difference can be 3 also, difference can be 7, 9, whatever it may be. ठीक है, these are some of the properties. I guess I have one question for you. Yes, here it is. Please answer this. What is the remainder when 15 power 71 plus 16 power 71 and so on is divided by 17? Answer fast. Yes, wonderful. This was very easy now for you. हाँ, रिमझिम is saying terms AP में ना होती, sum 40 ना होता तो पता नहीं. अगर terms AP में ना होती, then we cannot apply this method. Okay, let's move further. Answer is 0 here. Product of remainders we have already talked about. So we need to work with individual remainders. That's again easy question. Please answer this one. This is the next question now on your screen. This is the next question on your screen. Please answer. Sarvesh is answering 10. Some of you are answering 0. I guess you are answering for last question. Now answer this question on your screen. Yes, it's quite easy question. Rahul Raj, please recheck your answer. In Jila, we need to divide 120 also by 11. Na? We just don't need to just multiply the individual remainders. We need to further work on it. 10 is the right answer. See, 122 gives remainder 1, right? Because 121 is divisible by 11. So then here we are getting remainder 2, this is 3, then 4, then 5. Right? So this product now needs to be divided by 11. इसको सिर्फ multiply करके छोड़ नहीं देना है. This 120 is this product. Now this 120 needs to be divided by 11. This needs to be divided by 11. Now 110 is divisible, so remainder here is 10. That was a very easy question for you at this moment. Yes, answer cannot be negative. Always make sure, I have said it earlier also, I'm repeating it. While calculation, we may use negative remainders, but for answer purpose, remainder can never be negative. ठीक है, आगे बढ़ते हैं. Fermat's theorem, that is also we have discussed. So Euler's theorem के अंदर जब भी divisor is a prime number, that's known as Fermat's theorem. So it's not anything new. Answer this question now. 10 power 12. 10 power 12 divided by 13. अभिषेक previous question तो वो था ना 120 बन गया था ना 120 को हमें डिवाइड करना था 11 से 1 into 2 into 3 into 4 into 5 they were the individual remainders जिसको हमें 11 से डिवाइड करना था so that was 120 divided by 11 which gave you remainder 10 because 110 was divisible. That was the last question, Abhishek. Okay, in this question, yes, it's a direct question. You know that 13 is a prime number, so 10 power 12, this number power 12 will give remainder 1. So remainder is 1. So basically when divisor is a prime number, that theorem has a special name, it's known as Fermat's theorem. That was that thing. Okay, move further. Now this was about the factorial. Some of you were asking कि factorials के remainders भी करेंगे क्या? हाँ, Sagar, you can take a break in between, don't worry. So this Wilson theorem is there, which talks about the prime numbers regarding factorial numbers. हाँ, फॉर्मेट जाने दो, फॉर्मेट बीच में नाम आया था, अगर आपने कुछ देखा होगा तो, बट नॉट वेरी इंपॉर्टेंट. वो चीज हम कर चुके हैं ऑलरेडी, हमने लास्ट क्वेश्चन भी किया था. अरे बाबा, सी m raised to power 5 of n gives remainder 1 when divided by n, right? That was Euler's theorem, and its special case when n is a prime number actually. In that case, the phi value becomes p minus 1. That's known as Fermat's theorem. That's it. ठीक है ना? That is just a special case of that. So when the divisor becomes prime number, in that case, the value of phi, value of Euler number becomes p minus 1. That's it. That is known. This one is known as Fermat's theorem, or basically more specifically Fermat's little theorem. And this one is known as Euler's theorem. ठीक है? We have done this many times. Okay, now this Wilson theorem talks about the remainders of factorial numbers when divided by a particular divisor as prime number divisor. Is there any question here? Should we continue? What is the issue there? Yes, Shubh, we are taking example for this. ईशानी कौन से क्वेश्चन पे पहुंच गई हैं आप? 85, 17 into 5. We have many more things to do. We have just about 30 minutes remaining, and we have to cover 2-3 more things here. So please don't be inattentive. See here, now this Wilson theorem says p minus 1 factorial plus 1, that is divisible by p. Wilson theorem says that any prime number p divides p minus 1 factorial plus 1, which means basically p minus 1 factorial plus 1 is divisible or gives remainder 0 when divided by the divisor p. So here p is a prime number. This p is a prime number. So this theorem talks only about the prime numbers divisors. Prime number के अलावा उसके अलावा कोई divisor होगा, then Wilson theorem is not going to help there. But we can make use of various things. So let's take an example for this. So can you tell me any prime number less than 50? छोटा prime number लेते हैं. Any prime number less than 50. 2-digit prime number less than 50. Please write in comments. हाँ, Wilson का example हम ले रहे हैं. 11 थोड़ा ज़्यादा छोटा होगा नहीं? 13. Okay, 13 we can take 47 ले लें. Okay, let's take 47. 47 लेते हैं, ठीक है, चलो. 47 ले लेते हैं. So as per this theorem, if I'm dividing by 47, so 46 factorial, that is 47 minus 1, plus 1 is divisible by 47. That's what this theorem says. ठीक है, तो अगर कहीं पर ऐसा ही मिलेगा, in that case we can use it. That's a very specific situation, and as I remember, CAT में शायद factorials के रिमाइंडर निकालने का क्वेश्चन I don't remember. Maybe शायद कभी एक बार आया हो सकता है. ठीक है, so this is the result of the Wilson theorem. So factorials के लिए रिमाइंडर कैसे निकालना है? तो this is a specific condition, we should remember it. And one more specific case of this is, which will be very helpful, that p minus 2 factorial, मैं यहीं पे लिख देता हूँ पहले, p minus 2 factorial gives remainder 1 when divided by p. Because in the other theorems also we have found कि remainder 1 कहाँ मिल रहा है? I'm repeating it, कि remainder 1 कहाँ मिल रहा है, that is more important. So same thing we can use here also, that if we are dividing a factorial number by p, where p is a prime number, so p minus 2 factorial will give remainder 1. factorial means. That's what I was thinking. Factorial का meaning क्या है? Many of you may not be aware about that also. I'm telling you it. So p minus 2 factorial gives remainder 1. That is the result. That you must remember. Factorial क्या है? Let's understand this. So factorial of a natural number right now we are talking about. So factorial of a natural number. So factorial के लिए we use this symbol just like exclamation mark. So factorial of any number, let's say n, is basically product of all the natural numbers starting from 1 up to that number n. So 1 into 2 into 3 up to n. So this product is known as n factorial. I repeat. If I talk about say 3 factorial, so 3 factorial means 1 into 2 into 3. That is 6. Okay? Yes, multiplying. So multiplying all the natural numbers starting from 1 up to that number. So if I talk about 4 factorial, so it will be 1 into 2 into 3 into 4. That is 24. Right? Can you tell me in the comments what will be the value of 5 factorial? What will be the value of 5 factorial? Please write in the comments what will be the value of 5 factorial. Yes, 120. So 5 factorial means we just need to multiply 5 also. So basically 24 we had already calculated. So 24 into 5 because 1, 2, 3, 4 already multiplied. So 24 into 5 gives you 120. Okay, na? I hope you have understood what is the meaning of factorials. Okay, before moving further, one more question for all of you. Please tell me what will be the unit digit, your last digit of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial and so on up to 100 factorial. Find the unit digit of this number. Find unit digit of this number. Please answer fast. Some of you are saying 0. Mohit was asking 0. Now I can see other answer also 1, 3. Take your time. Be sure. Find out what will be the unit digit. Most of you are saying 0. क्या 100 तक का निकाल लिया क्या? 100 तक का कैसे निकाला? Yes, we are adding here 1 factorial plus 2 factorial plus 3 factorial and so on up to 100 factorial. Unit digit will be 3. Okay, let me ask Aratrika, how have you solved it? कोई trick है क्या? See, many of you are asking. Sarvesh has written after 5 factorial all will be 0. Wonderful thing. So we will get last digit by only first 5 terms. Wonderful. See, that's very nice thing. 5 factorial we have just calculated, it is 120. It is ending in 0, right? What about the next number? That will also end in 0. And all further factorials will be ending in 0. So if I need to find the unit digit of this sum, so all these terms are not going to contribute in that because they are all ending in 0, isn't it? So we just need to find the sum of the unit digits of these first 4 factorial numbers. This is simply 1, and this is 2 into 1, that is 2. 1 plus 2 makes it 3, and then 3 plus 6, it was 9, and then 9 plus 24, that makes it 33. So 3 is the right answer. Shubham says can't see the question. Okay, don't worry. Question was this one only. I'm writing it here again. 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial up to 100 factorial. We were to find unit digit of this. That's it. And we have just seen that after 4 factorial, all terms will be ending in 0 because their values are ending in 0. So we were to just find the value of sum of these 4 terms, which comes out to be 33. Okay, don't worry, we'll come back to this unit digit part after this. Repeat. Let's move further. Let's move ahead. Prince, it is not multiplication. They are addition, plus. They are all being added. Okay, I will come to it later. Let me create some space. ये बड़ा issue है यहाँ. See here. So question was 1 factorial. Question was find the unit digit of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial up to 100 factorial. We want to find unit digit of that. ठीक कैसे आया? See, we are not to mug up the answers. Answers का रट्टा थोड़ी ना मारना है. We have to understand how to solve. Unit digit निकालने के लिए what is the important part here? We have just seen what is the meaning of factorial. So 5 factorial is ending in 0, right? This ends in 0. And others are also ending in 0 because all of them are multiple of 10s. है ना? तो 5 factorial से आगे सारे ही numbers जो हैं, all these values are ending in zeros. They're all multiples of 10s. So basically we just need to find the unit digit from these first 4 terms. Now this value is how much? It's 1. And this one is 2. 3 factorial is 1 into 2 into 3, that is 6. And 4 factorial is 1 into 2 into 3 into 4, that is 24. if you just add them, because further all numbers are ending in 0. There's something ending in 0. So that is not going to contribute in the last digit. Shubham ji, do you know what is the value of 5 factorial? Please, let's see. What is the value of 5 factorial? Right, everyone? Shubham? And others, please tell me the value of 5 factorial. We had just written that earlier. 5 factorial is 120, right? Do you understand that? Only few students are writing, others those who are not writing, and they will write later. Didn't understand. All of you understand how to calculate it? It's simply product of all natural numbers starting from 1 up to 5. That is 1 into 2 into 3 into 4 into 5. That is 120, right? Now, what about 6 factorial? How to calculate 6 factorial? I just need to multiply 6 in this. What will be the value, please tell me? What will be the value of 6 factorial? Yes, 120 into 6. That is 720. Wonderful. It's 1 into 2 into 3, 4, 5, and 6. That comes out to be 720. So basically 120 multiplied by 6 only. This is also ending in 0. Will 7 factorial also end in 0? क्या उसके लास्ट में 0 आएगा क्या 7 factorial के end में? Yes, because I just need to multiply 7 in this. 8 factorial? Yes. So all further factorial starting from 5 factorials, they will have 0 as their last digit. Right? So if I want to find the last digit of this sum, so I just need to be attentive to these first 4 terms. Okay? Okay, let's move back to this Wilson theorem. So Wilson theorem, this is one of the things, and I just told you that the important part to remember is, please make note of this, that p minus 2 factorial gives remainder 1 when divided by p. And I already told that p is a prime number here. Okay? So that is the important result of Wilson theorem, so which we are going to use at many places. Let's take an example of that. Yes, Pranav, we'll be moving to the next topic after this one. First tell me, what will be the remainder when 40, let me write it here, 45 factorial divided by 47. Please tell me the remainder. What will be the remainder when 45 factorial is divided by 47? Satyam, p minus 2 मतलब p में से 2 कम करना है. What to explain about that? Yes, it's 1 directly. It's direct result. So p is a prime number. So here 47 is a prime number. So we can apply this theorem. Now 45 factorial. Now 45 is 47 minus 2. That's p minus 2. So as per this theorem, result is 1. Finished. That's it. Okay, let me do slight changes in this. I hope this part is clear to everyone. To use Wilson theorem, so that is a better result to remember and use. So please write it. And keep this in your memory and use it also. So I just made an example so that you can use it. I'm just making some changes so that it becomes more clear. Let me erase all these things. So I'm rewriting. So p minus 2 factorial gives remainder 1 when divided by p. So that is my important rule here. And question which I just discussed, that was 45 factorial divided by 47. So remainder comes out to be 1. Next question, please answer everyone. 40 यहीं पे लिख लेता हूं. चलो यहाँ पे 46 factorial divided by 47. Now tell me the remainder. (46 factorial divided by 47). It's not 0. 0 कैसे आया? Yes, Joy. 46 is correct. Nice. It's 46. See, 46 factorial plus 1 0 होना था ना. Plus 1 तो यहाँ पे है ही नहीं. Yes, minus 1 we can say, Sanskar. That's nice. Minus 1 of 46, right? So if I'm using that theorem, this result p minus 1 factorial plus 1. So 46 factorial plus 1 was divisible. So 46 factorial will give remainder minus 1. That is 46. That is one of the ways. But otherwise, see, this can be written as, this 46 factorial is basically 46 into 45 factorial. Is it okay? First, everyone please see this. Is 46 factorial, can we write it like this? 46 into 45 factorial. Joy, that is the wrong result. P minus 1 factorial mod p is p minus 1. Yeah, that's right. But that's not required. This much is sufficient. Just remember this. And other things we can follow from that only. Just remember this one result and we can make use of this to solve everything. So 46 factorial we can write as 46 into 45 factorial, right? Now I want to find remainder with 47. So 45 factorial का क्या remainder आएगा? We have just calculated it. It is 1. Isn't it? So answer is yes. 46 into 1. Thank you, Alisha. So this answer is 46. So no need to remember multiple things. कितना याद रखोगे? So this much is sufficient. So this is the shortest way, this is the shortest and best result of using Wilson theorem. So p minus 2 factorial gives remainder 1 when divided by p. हाँ रुचिका, अभी क्यों रट्टा मार रहे हो इसका? That's what I'm saying. No, don't take it as general result, and they will be mixed up then. Just use this one. Okay, take one more. If I ask you 48 factorial divided by 47. Now tell me what will be the remainder? 48 factorial divided by 47. 48 factorial divided by 47. Please answer. What will be the remainder? I can see 48, 47, 0. It is 0. Hey, Baba, it is divisible now. It's divisible. Because 48 factorial is containing 47 as well. This is multiple of 47. So remainder here is 0. Is it okay? चलो अभी तक के क्वेश्चंस में divisor was a prime number. What if it is not a prime number? What if it is not a prime number? If I ask you, what will be the remainder when 23 factorial is divided by 25? Now tell me. What will be the remainder when 23 factorial is divided by 25? Yes, 49 factorial will be 0 आएगा. Wonderful. Yes, it is again 0 because now don't see that कि -2 ही तो किया है. देखने में -2 लग रहा है, but this 25 is not a prime number, right? And 23 factorial means 1 into 2 into 3 up to 25. So there are many multiples of 5, right? There are 4 multiples of 5. So their product is certainly divisible by 25. So remainder is not 1, it is 0 here. The remainder is 0. It is not equal to 1. So don't get confused with this result. In this result, I told you that this P is a prime number. This 25 is not. ठीक है ना? So this is divisible here. So this Wilson theorem of remainders can be applied only when the divisor is a prime number. Right? Okay. So we had discussed many remainder theorems today, and in between we talked about bit of unit digit and last two days also. These questions you can solve very easily. Can you answer this one now fast? 22 factorial divided by 23. Remainder please. 22 factorial divided by 23. Yes, 22 is the right answer. Last one पूछ रहे हैं शुभ भाई. Last one was 23 factorial divided by 25, right? So 1 into 2 into 3 up to 23 we need to go. And in between you are having 5. In between you are having 15. And 10 also, right? And 20 also. So is this product not divisible by 25? It is divisible, right? So that's why it was 0. So we need to be cautious. Just don't remember the formula and apply them. Use intelligence also. Anyhow, this question we have already done. So this answer is 22. Why? As I said, just remember that part. This P is a prime number. Divisor is a prime number. 23 is prime. So 21 factorial will give remainder 1 when divided by 23. Now here it is asking about 22 factorial, which is basically 22 into 21 factorial. So 21 factorial is giving remainder 1. So here answer is 22. 22 into 1 is 22, not 23. Right? And this is a similar question. What is the answer for this one? 39 factorial divided by 41. Vidushi, just last part. You did the last two days, we will do later then. This is the last thing now. We are not going to do anything new now because time is almost up. Yes, this remainder is 1. It is direct use of that result. 41 is a prime number. This is the first thing to check. This is a prime number. That's fine. And now this is 2 short of that. So P minus 2 factorial gives remainder 1 when divided by P. So it is a direct application. So answer is 1. Right? One more question. What is the remainder when 340 factorial is divided by 341? Some of you are saying -1, some of you are saying 1. In between I can say 0 as well. Arey Baba, I told you first see that whether this divisor is a prime number. Is it a prime number? I don't think so. Is it a prime number? You haven't checked that. What are its factors? If it's not a prime number, can you find out its factors? हाँ, अगर वो नहीं पता कि ये प्राइम नंबर है या नहीं है, then you cannot apply. Yes, it is correct. Someone has written प्रयास. It's 11 into 31. This is 11 into 31. You need to first check this part. Now, is this number divisible by 11? Yes. From 11, remainder is 0. Is this number divisible by 31? Certainly. So with 31 also remainder is 0. So certainly it is divisible by 341. Answer is C, 0. ठीक है ना? So don't do this mistake. Directly result apply कर दिया -1 या +1 या something. No. First thing is to check whether the divisor is a prime number or not. Okay? ठीक है, ये पार्ट यूनिट डिजिट क्लास टुडेस वाला ये पार्ट हम नेक्स्ट टाइम करेंगे. सो वी विल स्टॉप इट हियर. सो आई हैव टेकन lot of time and thanks a lot for almost all of you have been throughout this more than 2 hours journey. So I thank you very much and I hope I know that there were many things overburden हो रहा था काफी लोगों को, but we will stop it here. The unit digit class to this part briefly we have discussed. We will discuss about it later in the further sessions. Okay, so thanks. That's it for now. Any feedback, comments you can write, and if there's any doubt, I'm still here. Thank you Prayas, thank you Vatsal, thank you everyone. What topics are remaining in numbers? कुछ topics हैं अभी in this class we were supposed to discuss about unit digit and last two digit also, but that's a small part. We will discuss it later. And I think you have done that you are doing that in your practice sessions as well. unit digit, last two digits. There's a small part which is remaining in this one. आकर्षिता कोई रिपीट बोल के जाओ. ओके थैंक यू एवरीवन. अच्छा 2 hours 43 minutes इतना हो गया क्या? हाँ यस ऑलमोस्ट. Okay, this is one question. No, 340 is not 340, बच्चे, it's 340 factorial. It's factorial symbol here. So it is product of all natural numbers from 1 to 340. That's why it is divisible by 11. ठीक है ना? Thank you everyone. What will be done in application class? I'm not sure about that, Prayas. I think remainders and all these things will be there. One class में सारे assignment questions solve करने हैं factors के. Yes, do that. Please solve as many questions as possible. LRDI कर तो रहे हैं. We are having a class. We'll be having a class I think on Thursday. This Thursday we'll be having next class of DI. Yes, जाओ खाना खाओ. And enjoy. After your class problem है किसी. सौमित्रा मजे नहीं लेने का. हाँ सौमित्रा मजे ले रहे हैं भैया. विल्सन थ्योरम, हर्ष विल्सन थ्योरम में हमने एक रिजल्ट किया, बस उसी को यूज करना है. लास्ट वही तो कर रहे थे ना. आई एम राइटिंग इट अगेन. जस्ट रिमेंबर एंड यूज दिस पार्ट दैट p minus 2 factorial when divided by p gives remainder 1. That's it. And make sure that this p is a prime number. Finish. Okay, मजा आया. Good night. थैंक यू. विदुषी एक डाउट सेशन रख लिया करो सो दैट क्लास कैन गो ऑन, वरना थोड़ा ड्रैग हो जाता है पुराने कॉन्सेप्ट्स क्लियर करने में. नो वरी, वो इट लुक्स लाइक दैट बट इट्स बेटर टू डिस्कस डाउट्स. डाउट से घबराना नहीं चाहिए. आई विल जस्ट से डाउट से घबराना नहीं चाहिए. डाउट्स हैं, कंफ्यूजन हैं, क्लियर दैट. सॉल्व मोर क्वेश्चंस. फिर से पूछो, नो प्रॉब्लम. बट उससे घबराना नहीं है. एंड बाय रिपीटिशन ऑफ द थिंग्स इट बिकम मोर क्लियर. I think I said in earlier session also that there are so many students studying together, so it is a very good opportunity to all of you that help each other by clearing their doubts. And if you are having any doubts, certainly get it clarified by anyone who is more knowledgeable than you. It may be your colleague, your other fellow students, or it may be any teachers available. But doubts का सामना करना चाहिए. Thank you Ankit. Good. There are various practice sessions and all. They are for that purpose only. And group is also there, so you can post your doubts in groups and you all help each other. Okay, thank you. So I will take your leave now.